Welcome to Jack and Universe. Let's embark on a wonderful adventure through the boundless realms of the cosmos. From time to time, we Earthlings witness the moon completely obscuring the sun. It's an amazing sight. But does a similar astronomical phenomenon occur on other planets, systems, and distant stars? Let's try to answer these questions. So, an eclipse is possible if a planet's satellites are large enough or close enough to obscure the sun for an observer on that planet. Also, the satellite, the sun, and the planet must be in the same plane. If a planet has no moon, forget the eclipse. For example, Mercury and Venus don't have them. Mars has two satellites, Phobos but they are too small to completely cover the sun for the notional Martian or Mars rover. But private solar eclipses do happen. Curiously, Mars itself often obscures the sun for Phobos. And there are seasons when this happens every day. But let's turn our attention to the giant planets like Saturn, Jupiter, Uranus, and Neptune. Their satellites are large enough to outshine the distant sun. But alas, these planets are made of gas. They have no surface. Of course, a total eclipse can be observed from aboard a ship, stated in the upper atmosphere of a gas giant. For example, Jupiter has 79 satellites. One of them is Ganymede, the largest satellite in the solar system, and they orbit in the same plane as Jupiter orbits the Sun. So all the conditions for an eclipse are in place. But what about dwarf planets like Pluto? Its companion Charon is big enough to obscure the Sun, but because it and Pluto face each other on the same side, the eclipse can only be seen in one of the hemispheres of these celestial bodies. Our moon, on the other hand, is very well placed. Apparently, it is only slightly larger than the sun. During an eclipse, the moon hides the veil, the brightest layer of the solar atmosphere, allowing us to admire the corona of the outer layer of the atmosphere. However, the moon is slowly moving away from us and will not be able to obscure the entire sun in the future. Someday Earthlings will observe only ring-shaped eclipses. But we should not be sad. The last total solar eclipse will occur in 600 million years. Humanity's eclipse will come much sooner. Of course, similar eclipses occur on other systems, and the sources of these eclipses may surprise you. Let's look at two amazing examples where eclipses last for years. In order to understand how unique the new discoveries are, it's first worth talking about the system of a bright star called Epsilon of the Emergent. Epsilon Emerged is about 1,600 light-years away from the Sun. Thanks to this, astronomers recalculated the characteristics of the components of the system, as well as conducted a computer simulation of its evolution. According to the results obtained, immediately after the formation of Epsilon Emerged consisted of a pair of stars. The mass of the first exceeded solar in 10 times. The mass of the second was less than 5 solar masses. When the less massive component of the system began to actively pull on the matter of its companion star, thanks to the increase in mass, it evolved much faster than its neighbor, and in 20 million years the system acquired its present form. The mass of the once larger star has decreased to just 2.2 solar masses. The luminary's large radius and brightness is attributed to the subsequent active loss of matter. However, an eclipse that lasts 2 years is not the limit. Let's pay attention to another interesting object, named Virgo C25056721, consisting of two components of a large red giant, producing the last days, and its already extinguished older brother, whose outer shells have already been thrown off and had time to cool down, turning into a huge cloud of dust and gas. In the center of this cloud, judging by the fluctuations in brightness during eclipses, is the core of the former star, which in the near future should turn into a white dwarf, whose mass should be about half the solar mass. The halves of the axis revolve around each other at a relatively large distance, about 20 times farther away than the Earth is from the Sun, which is roughly the distance between Uranus and our luminary. Because of this, an eclipse in this star system occurs every 70 years, and they last about 3.5 years. This is the longest eclipse on record. However, because of the too great distance to the star, researchers are not yet able to get images of each of the components separately, and also to check whether there is a planet in the vicinity of this double luminary. The next eclipse of the system will begin in April 2080 and will end in September 2083. By then, future astronomers will have new telescopes that can get a picture of it. Maybe nothing will show up anymore. Yes, eclipses have provided a wealth of material for science. In ancient times, observations of eclipses helped to study celestial mechanics and understand the structure of the solar system. For example, observation of the Earth's shadow on the Moon gave the first cosmic proof of the fact of our planet's imagery, although for some, it's proof of its flatness. Yes, it's really true. In the last 70 years, at least 700 stars have disappeared from our sky. But how is that possible? Let's find out. So, astronomers have compared star charts that were created back in the 10000950X years of the last century with those that have been made today. And over that span of one human lifetime, the sky has become different. Astronomers have made several assumptions about the cause of such colossal events, since this is a very small time interval. Some of them believe that the disappearance of stars can be explained by ordinary natural phenomena, such as failed attempts to form new stars or the absorption of stars by black holes. There is also a suggestion that they may have changed position and become distant. Another part of the researchers say that most of the missing stars are likely to have simply moved on to the next stages of their life cycle. This fact may well be an interesting topic for future research when the life cycle of some stars comes to an end. Their demise is marked by a supernova outbreak, a phenomenon in which the brightness of a star increases dramatically, gradually fading. The result of a supernova flash is a collapse into the densest object in his universe. Neutron stars, or mysterious black holes that are incredibly difficult to spot. Or perhaps they weren't stars at all, but a huge fleet of 700 ships from extraterrestrial civilizations. They just don't seem to be interested in us anymore. It's amazing how the sky changes more often than not that we can't see. In fact, 80% of Earth's inhabitants have never seen the night sky as it really is. It's all about artificial light sources that have caused light pollution. So, as sad as it is, nothing will change for some people even after another 70 years. Over many years of observation, astronomers have discovered many stars. The largest of these so far was Shields. The star's luminosity is about 120,000 times that of the Sun in the visible part of the spectrum. Taking into account infrared radiation, it is 340,000 times brighter than the Sun. The star loses a large amount of mass each year, making it the most enormous and fastest burning star known. However, that is not the case now. In 2020, like an asteroid on the head, came the surprising information that the star Stephenson 218 has become the largest star in the universe. Of course, of those now known, its radius was announced at 2,150 solar radii. This is a truly staggering value, as it deduces the volume of this luminary to be about 10 billion times that of our Sun hypothetically. If you put Stephenson 218 in the center of the solar system, its photosphere will easily swallow Saturn. Unearthed warms the frozen Uranus and Neptune. In other words, our Earth and us would be inside the blazing ball. Let's try to approach this giant and get to know it a little closer. It won't be easy, as the star is nearly 20,000 light-years away from us in the constellation Scorpio. Stephenson's star is 218. It's so huge that it's becoming unrivaled in size among other stars. Ever of the detected giant massive gas ball is actually a red hypergiant, a star of immense mass and size. Hypergiants are defined as the most powerful, heaviest, brightest, and simultaneously the rarest and shortest-lived giants. The mass of a hypergiant far exceeds that of any star, even a supergiant. For example, a typical hypergiant is 6 times more massive than a powerful star like Empire. The typical mass of a hypergiant, 120 solar masses or more, all the way up to 250 solar masses. The most massive currently known is thought to be WASP 6.1, having 265 solar masses. In size, hypergiants are no larger than the spheres of giants, but their masses are much larger, so they are approaching the theoretical mass limit, which is critical. On the verge of transition to the formation of a black hole, and extremely unstable luminosity of hypergiants can exceed 500,000 solar luminosity, and sometimes it is 1 million solar luminosity. These stars have extremely short lifetimes. Thus, the lifespan of a hypergiant is on average 1 to 2, at most a few 1 million years. The reason for this is that because of the enormous mass of the hypergiant must create enormous pressure to compensate for the gravitational forces to low-shit such massive stars is a great rarity in our galaxy. There are only about a dozen or so hypergiants. We now know a little bit about what kind of stellar dough the star Stephenson and 218 is made of. For the record, the star, as it turns out, was not easy to find. It was discovered in the JC2 star cluster, which is located in the constellation Scorpio. In this area was confirmed 26 red giants, which are representatives of the cluster. Moreover, this number exceeds the population of supergiants of other clusters. The recent study will detect about 80 red giants. About 40 of them have the best speeds comparable to the speeds of the objects of the cluster. The cluster is estimated to be between 14 and 20 million years old. The observed red giants with masses of about 12 to 16 solar masses are precursor stars of Type II supernova explosions. The clusters are largely obscured by dust and are not observable in visible light. But as we can see, not everything is hidden from the gaze of astronomers. It is in this cosmic zoo that our prize hypergiant was discovered, Stephenson 218. It is now known to be the largest star discovered and one of the brightest. A supergiant with a radius B21 50 times the radius of the Sun and a volume that would fit about 10 billion suns inside it. It's such a huge star that it's mind-boggling. So what else do we know about this giant? Current models of stellar evolution predict that helium thermonuclear combustion is already underway in the core of Stephenson N218. At the same time, hydrogen is still burning in the core shell when the fuel for thermonuclear reactions in the star finally runs out. The biggest giant ever found explodes as a Type II supernova. These are subcategories of supernovae stars, which in turn are subcategories of cataclysmic. Such variable stars. The explosion will leave behind a nebula with a neutron star at its center. Although some believe that the star Stephenson 218 bright representative of a black hole, after the explosion what size the hole will turn out to be, it is difficult to say. Unfortunately, because the star is so far from our Earth, it cannot be observed because it is too dim despite its size. Nevertheless, the existence of these stars seems to be enough to give us an idea of how small our Earth is, how tiny we are in a universe that is bigger than we can imagine. The growing red giant Beta Giza is beautifully visible in the night sky. The star burns higher than Orion's belt, located in the constellation of the same name. The luminary continues to grow in size. The outer gas envelope of Beta Giza is inflated unevenly, from what the star skewed quite a bit. The cause of this phenomenon is hidden in the magnetosphere of the red giant, which makes the star pulsate and shake. The most likely scenario for the end of the star's evolution is that Giza will eventually undergo a Type II supernova explosion, although it is possible that the star will not explode and will shed its shells in the form of a planetary nebula, remaining a white dwarf of the rare oxygen non-oxygen type. But when will a star explosion happen? No one knows for sure. It can happen with the same probability tomorrow, for example, while molding dumplings, or even in hundreds of years, when you think to change the next implant. In the event of an explosion, the Beta at Giza could increase its brightness by at least 10,000 times. Shine with the brightness of a crescent moon. The explosion would last for months. The star will be easily visible during the day and will look like the glowing colors of glowing red-hot glass. After the explosion, the star's luminosity will gradually decrease, and within a few months or even years it will no longer be visible to the naked eye. Orion's right shoulder will disappear for a while, and in a few centuries a nebula will appear in its place. However, if the axis of rotation about Giza is directed to the Earth, there will be more tangible effects on the Earth will be directed a stream of gamma rays and other cosmic particles. There will be strong auroras and, perhaps, a noticeable increase in the number of cosmic particles that have reached the surface of the Earth. In the case of such a scenario in relation to the solar system, the flare would also be many times brighter than if the axis of the star was pointing away from us. The explosion at Giza will shine half of the Milky Way, and the nearest planets will be covered with a cloud of radiation and high-energy particles. Earthlings, however, have nothing to fear. The red giant is too far away from our planet at a distance of about 600 light-years. Critical for mankind may be the explosion of a supernova within 30 light-years. If mankind is threatened by anything, it's not from outer space. In any case, a supernova explosion would be a huge astronomical event. So keep your sunglasses on. In the constellation of Swan occupies a vast area of the celestial sphere. If you add to the bright stars that form a characteristic geometric figure and numerous faint stars, then with a little effort of imagination you can see a flying swan. This is how this constellation was depicted on ancient and star maps and star classes in the constellation of the Swan. It is located in the constellation Swan in the northern hemisphere of the celestial sphere. Its bright stars are arranged in the shape of a cross that extends along the Milky Way. This shape was associated by the ancient Greeks with a flying bird. In mythology, the swan is inextricably linked with Arsenius. According to a fictional legend, it is a singer and musician born of a river god and the music of a linden tree. The poor man was mauled by maddened creepers, and then Zeus arranged in the sky two constellations, Lyra and the Swan. The latter represents Orpheus. And we will proceed to the most interesting objects of this constellation. First, let's turn our attention to the Deneb star or Alpha of the Swan. It's a white light, a giant. Its luminosity is 67,000 times that of the Sun. It is about 2,600 light-years away from Earth. It is the farthest star and is almost twice as bright as the others. Its mass is estimated at 20 solar masses. In one day, Tenet emits as much light as the Sun does in 140 days. In Arabic, the star's name means tail. On the other side of the swan's body is the star Albert. In the night sky, it is visible to the naked eye, and in a telescope it is seen as a double star system from the blue planet. It is at a distance of 400 light-years. The main star of the system, or Albert A, is the orange giant of the second luminary. Albert B is a rapidly rotating blue star of the main sequence. From Arabic, the name translates to the beak of a chicken. Of course, to the cosmic chicken star Sauter or Gamma Swan is located at the intersection of 5 stars, which are called the Northern Cross. From Arabic, the name translates as the breast of the luminary. It is one of the brightest in the constellation. It is separated from Earth by 1,800 light-years with an error margin of 15%. Its mass is 12 times that of the Sun, and its radius is 150 times. In terms of its temperature regime, it belongs to the type. Next, consider the Delta Swan, which is the third largest star. It has the traditional name of Rook. This triple star system is 170 light-years away and consists of 2 nearby stars and 1 distant one. The brightest luminosity is a blue-white giant. Its luminosity is 180 times greater than the solar. Radius exceeds the radius of the Sun in 4.7 times and mass in 3 times. Next to it is a yellow-white star. Its luminosity is 6 times that of the Sun, and its mass is 1.5 times greater. The third component, an orange star, loses out to the Sun in every way. Epsilon of the Swan, or which in Arabic means the wing of the raven. It's 73 light-years away from Earth. Its luminosity is 62 times that of the Sun, and its radius is more than 11 times greater. It is a giant star that has already left the main sequence and started its last stage in the stellar evolution of 1903. Its spectrum serves as the benchmark by which other stars are classified. In the solar system, a star the size of half the Sun is hurtling along at about 50,000 kilometers per hour. When will it come close to the Sun? Planet Earth will be hit by a rain of rock that will last 1 million years. But it's a little early to build a shelter. Its appearance is expected in about 1.5 million years. We are talking about a star near 710, which is now 64 light-years away from the solar system. The star is predicted to pass by Earth in just 77 light days. For comparison, the closest star to Earth other than the Sun, Proxima Centauri, is more than 4 light-years away. Of course, in 710, it will not collide directly with Earth, but it will pass through the Oort cloud. This is a region around the solar system consisting of 1 quintillion comet nuclei more than 1.5 kilometers in size, which is the source of the debt of periodic comets. Its outer boundaries are 1 light-year away from the Sun. It is thought that the gravitational field beyond 710 could cause a perturbation in the cloud. This will cause the objects in it to enter the solar system in large numbers and with a high probability of crashing into the empty Earth. In addition, the star can change the orbit of Neptune, for ZA 710 is not the only star to be regarded with apprehension. After all, there are many virtually invisible red dwarfs whose exact trajectories are still unknown. Hopefully, in time, the telescope will investigate them and make measurements as accurate as in the case of Grizzly 710, or even more accurate. It is likely that among these stellar dwarfs there are some that threaten the solar system with a collision. We just don't realize it yet. At a distance of about 16,000 light-years away, the Maxi star system 1621501 has been discovered. This strange point in space was first characterized by what seemed at first to be unpredictable flashes of X-rays. It was later learned that in neutron stars, the X-rays come from thermonuclear explosions on their surface. Amazingly, the thermonuclear explosions do not occur side by side, but followed a pattern that repeated every 78 days, like a super precise clock. And it's mind-boggling. Of course, we would love to see how these objects form and what happens on the surface of neutron stars, but they are so far away from us. Our astronomical facilities don't have the kind of instruments that would allow us to see everything in detail. But sometimes the most interesting experiments in physics can only be done in your imagination. Despite the physical limitations that do not allow us to go anywhere, dissect and examine in detail any object of interest in the universe, our understanding of matter in all its manifestations and the laws that govern it has advanced quite far. We propose to take such a journey together to a neutron star. To date, we know that a neutron star is a compressed core of a massive star of very dense carbon, left over from a supernova. Its mass is comparable to that of the Sun, but it's compressed to the size of a city. So neutron stars serve as a denser reservoir of matter in the universe. The last matter at the edge of a black hole is a newborn neutron star. It's a very hot object. The temperature of the interior exceeds 1 quadrillion degrees for some time. For about the first 100,000 years of its life, the neutron star cools mostly not from the surface, as any normal body does, but from the center by emitting neutrinos. At this time, the temperature of the interior is hundreds of 1 billion degrees. It is then that the terribly amazing process of heat flows deep into the star, where in a sense it disappears as the neutrino is free to leave the interior of the neutron star. To drill into such a star, we would be approaching the cutting edge of science. A couple of centimeters of normal atoms, mostly iron and silicon, lying on the surface like a bright red coating of the densest candy in the universe. Then the atoms shrink so much that they lose electrons, falling even deeper into the common sea. Protons begin to turn into neutrons so close together that they begin to overlap, giving rise to matter unknown to us. Although, as of today, from a nuclear physics perspective, neutron stars may simply be made up of protons and neutrons. In other words, clones. Clones, as we know, are not elementary particles. After all, they're made up of 3 quarks. Under incredibly strong pressure, quarks can form a new quark state, their matter, which is in a single quantum state. So, the closer to the surface, the lower the density. But neutron stars have one cosmic trick, except for a thin, less than 100-meter layer near the surface. They've almost the same temperature everywhere, so the base of the outer crust gets pretty hot. If we are talking about a young and not too heavy neutron star, for example, hundreds of 1,000 years old or less, this temperature will be hundreds of 1 million degrees Celsius. As a result, the outer layers can melt. This usually happens at a depth of a few tens of meters from the surface. This is where the strange ocean of water of this ocean, this so-called new liquid, begins. As we realize, we can't do a circumnavigation. The composition of this mass can vary from hydrogen to iron. It is in this layer of a neutron star that the temperature jumps from hundreds of 1 million degrees at the bottom to 1 million at the surface. The density of matter in it is tens of 1 million times the density of water. It's as deep as the Sea of Azov. But the ocean covers an entire star, even if it's the size of a city. Many of the young single neutron stars that we observe due to the thermal radiation of their surface from the outside are actually liquid. That is, we see the surface of an ocean gradually transitioning into the dense atmosphere of the neutron star. In the presence of a powerful airstream, there is thermonuclear combustion of hydrogen and helium under the ocean. The latter is converted, as a rule, into carbon. So basically, the ocean will be made up of just that. I'd like to call it a liquid diamond, because the pressure there is gigantic, but that would be an exaggeration, because we are waiting for a completely different world. Heated to almost 1 trillion degrees Celsius ocean of carbon with a density 10 billion times greater than that of water, and it all explodes. It's called thermonuclear combustion. The flash lasts about an hour, and in that time it releases as much energy as the sun puts out in 1 year. So much energy that it's carried away by neutrinos. And it's these flares that we see from planet Earth. But not every neutron star has a carbon ocean that ignites frequently. It's necessary for the matter at the point of collapse not to grow quickly. Then there will be an area of particularly high temperature and density. What's also interesting is that on any ocean there are waves. Is it possible for a neutron star to make a big wave in the ocean? Neutron and stars? Difficult. High density and very strong gravity gets in the way. But you can build liquid mountains, hold matter together, shake Kanye, and help the strong magnetic field. Of course, on a neutron star, everything happens very fast because of the strong gravity. The gravitational acceleration on the surface is 100 billion times greater than on Earth. That means that a pendulum that swings in 3 seconds on a neutron star would swing in 100,000th of a second on a neutron star. Strong gravity causes the elements to rapidly separate into light and heavy elements. In the ocean, the heavier elements quickly go to the bottom and the lighter elements remain on top. This happens over a period of days or months. So the ocean, unless it has convection, is likely made up of distinct layers with different compositions. That is, even if you stir up a stellar mare, very quickly the neutron mass will still end up at the bottom. This can only be prevented by turbulent mixing, arising from the large temperature difference in different parts of the ocean surface and the Hall effect. Whatever is in the core of a neutron star, free quarks, clone condensate, hyperbolas, or good old tilts, all this material must hold against the crushing gravity many times greater than the solar. Otherwise, the star would slam into a black hole. But different materials can be compressed by gravity to different degrees, which determines the maximum possible weight of a star for a given physical size. Neutron stars are truly amazing objects, but not fortunately, they are very far away. And tiny as they are today, it's very difficult to measure anything but the most basic properties from them. To make matters worse, the most interesting physics is going on beneath their surface. The situation is like a laboratory where something amazing, something secret is going on. Hopefully, with a new generation of equipment, theorists will finally be able to take a real look at neutron stars. And 1987, a supernova star erupted at the edge of the Taranto Nebula in the Large Magellanic Nebula, a cloudy dwarf galaxy satellite of the Milky Way about 168,000 light-years from Earth. The explosion of the star resulted in the ejection of huge amounts of gas into interstellar space, releasing huge amounts of radiation and neutrinos. The light of the outburst reached Earth on February 23, 1987. A little later, in February 1, 988, a light echo of the supernova was detected. It represented 2 concentric rings, which were created during the flare on the gas-filled clouds. Which begs the question, what is a light echo? Briefly, a light echo is a phenomenon observed in astronomy. By analogy with the sound echo, light echo is a sudden flash of light when light is reflected from objects outside the source and arrives to the observer some time after the first flash. Due to the peculiar geometry of the phenomenon, light echo can generate the illusion that the light comes to the observer over light speed. Let's take an example. So, the reflected light traveling along path B arrived shortly after the flash of light traveling along path A and before the light traveling along path U of the path. B and C have the same length in Earth. They appear to have arrived at the same time, although there can be a very long distance between the points where the light reflected. So, it took about 170,000 years for the brightest flash of light from the supernova to reach our Earth. part of the light flux reflected by the two field layers near the supernova was already visible after the star had faded, because the scattered light had to travel a long way. The dust that caused the rings visible in the photograph lies in two different layers about 470 and 1300 light years away from the supernova. This color image was constructed by computing images on photo plates taken before and after the supernova, and is an accurate light reproduction of the extremely faint light echo that replicates the yellow color of the supernova at the time of its maximum brightness in May 1987. Other known series of light echo images have been obtained by the N2 and Super Macho Sky tracking projects. And then comes the realization that you don't have to be Batons to be interested in space. So welcome aboard. The study of self-expanding rings of light echoing from other supernovae has allowed us to pinpoint the position and dates of these grand stellar explosions and study their symmetry. Supernova 1987A remains the closest supernova since the invention of the telescope. More recent observations have shown that the supernova continues to change shape, and today we can see the expanding fireballs left over from the star's explosion. These high-resolution images show two clots flying out from the center of the explosion. It should be remembered, however, that the term supernovae should not be associated exclusively with exploding stars. These phenomena are perhaps as diverse as the stars themselves, and science has yet to understand many of their secrets. I suggest that today we do a little investigating and find out what's behind them. A macro flash in deep space. In simple terms, it's a titanic explosion that produced gravitational waves and gamma rays. But how did it come about and what was left behind? Believe me, it's a very interesting case. So, on the morning of August 17th, 2017, automatic systems on one of the two detectors of the LIGO Gravitational Wave Observatory recorded the arrival. Gravitational waves, indicating some kind of grand cosmic event accompanied by the release of huge amounts of energy. The signal is labeled JD 170817. This was the fifth time gravitational waves have been detected since 2015, since they were first recorded. Just 3 days earlier, the LIGO Observatory had first heard a gravitational wave with the European Vega project. However, this time, just 2 seconds after the gravitational event, the Fermi Space Telescope detected a gamma-ray burst in the southern sky. Almost at the same moment the flash was seen by the European-Russian Space Observatory Integral. What was it? Obviously, a random coincidence of these two events is extremely unlikely. And it is indeed so, because in the search for additional information was found that the gravitational wave was seen and the second detector, or did not fix the European Gravitational Observatory Virgo. Astronomers around the world were puzzled by the hunt for the source of gravitational waves and gamma-ray bursts started by many observatories, including the European Southern Observatory and the Hubble Space Telescope. The task was daunting. The combined data from the 4 observatories helped delineate an area of 35 square degrees. That's the approximate area of several hundred lunar disks. It wasn't until 11 a.m. that a small SWP telescope with a meter mirror, located in Chile, took the first image of the suspected source. It looked like a very bright star near the elliptical galaxy Angie USSR in the constellation Hydra. Over the next 5 days, the brightness of the source dropped by a factor of 20, and the color gradually shifted from blue to red. All this time, the object was observed by many telescopes in the ranges from X-ray to infrared, until, in September, the galaxy was too close to the Sun and became inaccessible for observations. Estimates of the object's distance, derived from both gravitational wave data and other observations, gave voting results. J 170817 is at the same distance from Earth as the galaxy, which is 130 million light-years. Yes, that's very far away, but it's the closest gravitational wave source ever detected and one of the closest gamma-ray burst sources ever observed. And the source of the wave was the merger of two objects with masses between 1.1 and 1.6 solar masses. It could only be neutron stars. For the record, these are very important elements for building entire worlds in the universe. But that's not all. At this point, radio interferon has detected something very strange. Sometime after the stars merged, it detected an area emitting radio radiation, and it was moving so fast that it could be explained by an ultra-fast jet of plasma. Now the neutron star remnant is surrounded by a dense cocoon of glowing gas, which collided with the beams of plasma ejected during the merger of these objects. This collision bolted the gas and accelerated it to about 50% of the speed of light, causing it to glow. The existence of a hot gas cocoon explains well many features of the merger. For example, the sequence in which the effects of the flare would be observed in different bands of the electromagnetic spectrum, and the fact that this object would become increasingly bright in radio waves. What is left after the neutron star merger? It could be either a black hole or a new neutron star. In any case, this relatively detailed neutron star merger was the first new outburst in history in which several phenomena were detected at once: gravitational waves, electromagnetic waves including gamma rays, X-rays, visible light, and radio waves. Simply put, it was an explosion of a celebratory firecracker of universal proportions observed by all the inhabitants of the nearest worlds, including ours. I hope you found our investigation interesting. Be sure to hold on to your sweet tooth and patriarch, where additional material awaits you. Believe me, it helps a lot in the development of our channel. In conclusion, I offer you something very interesting. Actually, to listen to the very signal of neutron star JW 170817, but only converted into sound. It's an amazing phenomenon that lasted 30 times longer than any previous signal. Gravitational waves in the history of exploration. And there are white dwarfs, the remnants of stars like our Sun that have gone through the major stages of evolution and are now slowly but continuously cooling. And there are neutron stars, formed when stars much more massive than our Sun collapsed in a supernova explosion. Their mass and density are so great that electrons literally pour into protons and result in neutrons. 1 teaspoon of neutron star weighs about 10 million tons. How much do you want in your tea? A teaspoon? And then there's the black hole. They're formed by even more powerful supernova explosions. And their gravity is so strong that even light can't escape their nets. White dwarfs, neutron stars, and black holes. They were all originally just physical theories that were then subjected through direct or indirect astronomical observations. And that's about it. That's the entire list of exotic objects that stars can turn into from what we've discovered. Yes, however, there are some even stranger objects that are still just theories. For example, quark-new stars. But what are they? And is it related to frogs? Let's go back to the neutron star. According to the theory, neutron stars have such a powerful gravity that protons and electrons merge to form neutrons. So the entire star is made up of neutrons both inside and outside. And if you increase the mass of a neutron star, the line will be crossed where the neutron star is no longer stable and is smashing into a black hole. Ordinary stars, such as our sun, have a certain structure. A temple crown, a sphere, a photo, a sphere, a zone, and net transfer beam, an active zone, and a solar core where fusion reactions take place. This may be the case. Neutron stars under certain conditions turn into other objects that have a different structure. The theory suggests that a quark star is an intermediate stage between a neutron star and a black hole. It has enough mass in its core to collapse the neutrons and allow the quark to move freely, but not so much that it completely collapses itself and becomes a black hole. Astronomers have discovered a rather interesting class of supernovae that emit about 100 times more energy than normal supernovae. Such supernovae may well turn out to be heavy, unstable neutrons, stars that have exploded a second time, for example as a result of absorption by a companion star. And under certain conditions, they could turn from an ordinary neutron star into a strange quark star. And let's imagine that quarks and stars do exist. What would they be like? From the looks of it, they should be small objects, while a normal neutron star is about 25 kilometers across. A quark star would only be about 16 kilometers, and that's pretty much the limit after which the star is bound to turn into a black hole. The lifespan of quarks and stars will also be much shorter than that of a neutron star. Astronomers have long been busy searching for quarks and their stars, and will continue to do so in the future. What do you think about the quark and star theory? It is thought that there are 10 times the number of stars even within the boundaries of the observable universe. A grain of sand on every beach in the world. Of course, even the gaze of the most powerful modern telescopes can see an unimaginably smaller fraction of them. In the search for a stellar leader does not help, and the fact that the largest stars can stand out with their luminosity. Whatever their brightness, it fades when observing distant galaxies. The brighter stars are not the largest, so finding the largest star in the universe will not be as easy as it seems. But what we know already today is awe-inspiring. Before we answer the question, which star is the largest and what is it? Let's look at our own sun. Our mighty star is 1.4 million kilometers across. The sun makes up 99.9% of all the matter in our solar system. And although there are approximately 1 million Earth-like planets that would fit inside the sun, this star is only a stellar baby compared to other hypergiants. I suggest we look at a list of the 10 largest stars from smallest to largest object. And we'll start with the famous Gates Battery Star. This red supergiant is located just 640 light-years away from our planet in the constellation Orion. Its size is 1,180 solar radii, It is believed that the geyser could be reborn as a supernova at any moment, and we will be able to observe this most interesting process almost from the front row. 9th place, GW Sophia. There are still debates over the dimensions of the fourth representative of the constellation Phae, but the approximate size of this giant is 1,300 solar radii. The 8th place, double Sagittarius, is located in the constellation Sagittarius. The red supergiant is 1,460 times the radius of the Sun. The 7th place Swan is a star at least 1420 times larger than the Sun. But according to some calculations, it could even top the list. The argument is strong. 2,850 solar radii. However, the actual size of the celestial body is likely close to the lower limit, which brought the star to the 7th line of our ranking. The luminary is 5,000 light-years from Earth in the constellation of Swan. 6th place, B30054e. This red hypergiant is quite a bit behind object as many as 64. It's 1,520 times the size of the Sun. The star is relatively close at only 9,000 light-years from Earth in the constellation. 5th place, OG64. It was previously thought that this red hypergiant could rival the Big Dog in size. However, it was recently revealed that it is a star and the constellation of the Goldfish, only 1,540 times larger than the Sun. It is located outside the Milky Way. There is a large cloud in the dwarf galaxy. 4th place at 838 Unicorn. It is a red variable star, located in the constellation Unicorn at a distance of 20,000 light-years from Earth. Perhaps this luminary is even larger than Phae and Lucifer, but the huge distance separating the star from our planet does not allow for more accurate calculations at the moment. Therefore, it is usually attributed to her from 1,100 to 1,500 solar radii. Lucifer's third location is in the same constellation. This red supergiant is 1,650 times larger than the Sun. In addition, Lucifer is one of the brightest stars in the Milky Way. It is more than 38,000 times brighter than our luminary. 2nd place is taken by an object called the Big Dog. This red hypergiant has left all its competitors far behind. The star's radius is estimated to be 1,800 times that of the Sun. If Big Dog Lie is the center of our solar system, its edge would be close to Saturn's orbit. This star is about 1,000 light-years away in the constellation of the Big Dog. Yes, this star is huge, but it is not at all the one that takes the top spot. Meet the giant star leader, the Shield supergiant. Supermassive objects, 9,500 light-years away from us, and is observed as a dim variable star, barely visible in a small telescope. Radius, according to current estimates, is 2,100 radii of the Sun. The size of the object is monstrous. To illustrate, let's take an example. If we imagine our Earth as a buckwheat pizza and the Sun as a watermelon, then the diameter of the shield will be comparable to the height of a house, which is 540 meters or a 45-story house. It would take as much as 8 o'clock to fly around such a star at the speed of light. Must remember that the light, and descended by the Sun, reaches our planet in only 8 minutes. If you fly at the same speed at which the ISS for an hour and a half makes one revolution around the Earth, the flight around its shield will last about 36 years. But what's interesting to note is the monstrous size of the shield is completely incomparable to its other parameters. This star is only 10 times more massive than the Sun. It turns out that the average density of this supergiant is almost 1 million times lower than the density of the air around us. For comparison, the density of the Sun is 1.5 times the density of water, and a grain of matter of a neutron star weighs 1 million tons. Roughly speaking, the average matter of such a star is similar in density to a layer of atmosphere located at a height of about 100 kilometers above sea level. This layer, also called the pocket line, is a conventional boundary between the Earth's atmosphere and space. It turns out that the density of this shield is only slightly less than the cosmic vacuum. It feels like a star about to burst, nor is its shield the brightest. With an intrinsic luminosity of 340,000 solar luminosities, it's dozens of times dimmer. Of the brightest stars, a good example is Star 6, which is the most massive star known today at 265 solar masses. At the same time, the star is only 6 times the size of the Sun. It turns out that 106 is 20 times brighter and about the same number of times more massive than the shield, while being 50 times smaller than the giant. Yes, as you may have guessed, her shield is nearing the final stages of its evolution. Like all giants, it has begun actively burning helium and some other heavier elements. According to current models, in a matter of 1 million years its defense will successively turn into a yellow giant, then into a bright blue variable or wolf heaven star. The final stage of its evolution will be a supernova explosion, during which the star will shed its shell, most likely leaving behind a neutron star. Already today, its shielding is showing its activity as a regularly variable with an approximate pulsation period of 740 days. Given that the star can change its radius from 1700 to 2100 solar radii, its rate of expansion and contraction is comparable to that of spacecraft. Its mass loss is at an impressive rate of 58 million solar masses per year. Yes, the star is the largest known star. Its size is truly shocking and terrifying. It's hard to imagine that there are even bigger stars. All of the objects discussed today are highly unstable and short-lived. Such stars can live for as little as 1 million or even hundreds of 1,000 years. Therefore, observing a giant star in another galaxy, we can be sure that now, most likely, in its place is a pulsating neutron star or even and fused space. A black hole surrounded by the remnants of a supernova explosion. If such a star were even 1,000 light years away, one cannot be entirely sure that it still exists or has remained. The same giants. Back in 1596, amateur pastor and astronomer David Fabrizio noticed the appearance of another new star in the sky. He traced to the weakening of its close and lost interest in it, because the new ones did not tend to reappear. But suddenly, 13 years later, he found the star in this same place again. Knowing nothing about the discovery of Fabrizio, Johann Bayer in 1603 introduced this object in the atlas of the starry sky under the designation micron whale, having a luster of 4-star magnitudes. But it was not until 10 years later that it began to be observed systematically. Jan Willi observed the star for 23 years and gave it the name Mira, which is Latin for amazing. What was it that surprised the astronomer so much? Let's find out. So, the star is located at a distance of about 420 light-years from Earth in the equatorial constellation of China. When bright enough, it can be found in the area between the brightest star in the head of the whale and the fainter star that marks the belly of the mythical sea monster. The best times to observe are October and November. By the middle of the 17th century, it was finally determined that the mysterious star from the constellation of Whale is variable with a very long period of 332 days. It has since topped a special class of stars, the long periodic variables known as myriads. This discovery, combined with observations of supernovae, proved that the starry sky was not something eternally unchanging, as taught by Aristotle and other philosophers of antiquity. That, in general, sparked a revolution in astronomical views of the universe. The cause was just the world and Whale, one of the most amazing cosmic objects. Not only that it noticeably changes its brilliance in the firmament, but it is also a double system where one star pulls matter from the other. How exactly does this happen? The Micron Whale system consists of a red giant world about 6 billion years old and a hot white dwarf Micron Whale 70 astronomical units away. The two stars form an ethical pair to themselves, closest to the sun of the world. The is surrounded by a hot agitational disk of matter emanating from the giant. It is also variable because of the irregularity of the influx of matter. The apparent stellar magnitude varies between 9.5 and 12. Observations made by the Chandra X-ray Observatory have shown the presence of a bridge of matter flowing from the primary star to the companion. Mira is thought to lose about 1/millionth of the Sun's mass per year, or about 1 Earth mass every 10 years. Mira Whale is a star in the final stage of evolution, but it will not end its life as a supernova because its mass is not large enough at only 1.2 solar masses. Instead, the star will relatively soon shed its outer shell, forming a planetary nebula and gradually fade away as a white dwarf. The amazing features of the star do not end there. Most stars in the Milky Way orbit slowly around the center of the galaxy, moving at roughly the same speed and in the same direction as interstellar gas. Mira, however, breaks from the general pattern. This star is flying through a galactic cloud of gas at 130 kilometers per second. The matter it ejects is simply blown backwards, forming a unique tail formation. Yes, we are talking about a huge stellar tail consisting of dust and gas, like those that extend behind the comets flying to the sun. The discovery was made using the Hubble Ultraviolet Orbiting Telescope. Astronomers were quite surprised, as the world has been studied for 4 years, and so far no one has noticed any special oddities in it. However, the explanation is quite simple. No one has observed it in ultraviolet light. The detected tail extends as far as 13 light-years into space. In comparison, the distance to the nearest star to the Sun, Proxima Centauri, is only 4 light-years. According to calculations, it took at least 30,000 years for such a tail to form. The photos from the ALEX telescope clearly show a gull and a swell in front of the star. This is the shock wave. The area of the head spike is compacted. Something similar forms in front of a bullet traveling at supersonic speed. The matter ejected by the star experiences a head-on collision with particles of interstellar gas. As a result, it heats up and rushes towards the tail. The bulk of this matter is made up of hydrogen atoms. They gradually lose the energy they have gained, releasing it in the form of ultraviolet rays. And that's what Alex's telescope detected. By piecing together all the facts about the star, Mira can rightly be called amazing and unique. A cold red giant of a comet, rushing at tremendous speed with its hot companion and leaving an incredible-sized tail pulsating. The star that began the history of the study of variable stars. A star preparing for the end of its life stage and preparing, having shed its matter, to give birth to something new. The constellation of Leo is one of the oldest, and it is known since the time of the Sumerians of ancient Egypt and Greece. Therefore, the origin of its name in each nation is different. For example, in ancient Egypt, this constellation in March and April rises almost to the zenith, and at this time there began a terrible drought. Hungry lions would begin to roam the desert in search of prey, and the neighborhood would be silhouetted by their roaring. This was the time of the lions, and it coincided with the finding of a certain constellation in zenith. That is why it was called the constellation of the lion. It is also noteworthy that the name of its main star from Latin translates as king. Another version of the origin of the name of the constellation is better known. It represents the same German lion from Greek mythology, which killed Hercules in the course of the quest to accomplish 12 famous feats. No one was able to kill the lion, as the hide was not amenable to any known weapon. Heracles tried to use arrows, but they bounced back. So he drove it into a cave and strangled it. To skin it, he used the claws of the beast, after which he wore the coat like an invisibility cloak. Of course, we have a question and whether the outline of the constellation is really so similar to the lion. It is clear, and without moon night in the constellation of Leo with the naked eye can be seen about 70 stars, but mostly these are faint stars, connected mentally by lines. The brightest stars form the characteristic geometric figure of the constellation of Leo, strongly elongated, irregular of 6 angles. A little bit of imagination, and in this figure you can see the body of a lion with an exuberant mane. Let's turn our attention to the star. Riga is the most important object in the constellation of Leo. The star is almost of the center of the constellation and is often compared to a heart. It is the brightest luminary, being 160 times brighter than our sun. This star is located 85 light years away from us, which explains its high apparent brilliance. Dennis Bola's star is the second brightest object that belongs to the lion. It is a red star that is often referred to as the tail. The double star, for one of the most beautiful in the sky, denotes the majestic mane. If you look closely, the slightly orange star has a noticeable golden companion. The orbital period of this double system is approximately 510 years. Of course, there are many interesting galaxies, galaxy clusters, and even quasars in the constellation of Leo. I suggest we take a look at some of them. The spiral galaxy M65, M6, and NGC T28. As a rule, This trio of galaxies is not separated even when observed in a telescope. The entire system of galaxies is 35 million light-years away from us. M65 plus NATO is an elongated galaxy. It holds a small amount of gas and dust, although the spiral arms show signs of recent star birth. This process is not very active in the galaxy itself, so it is populated by old stars. Existing areas of star birth and deformed. The disk hints at contact with large neighbors such as Galaxy 60, which is of the spiral type in cross-section. It's 100,000 light-years across. The galaxy has such an elongated and slightly stripped shape due to gravitational interactions with two other galaxies. The faintest, but at the same time the most beautiful galaxy in this trio is Angie and T28. It can be seen from the edge, and with careful detailed study you will be able to distinguish the deformation of the arms. The entire trio forms an interacting galactic object known as the three-line plates. It's a bright galaxy cluster of spiral galaxies, and we'll follow it up next. Notice the galaxy N5 or NGR1. It's about 40 million light-years away from us. The arms form an almost perfect circle near the galactic center. They are further developed and resemble a luxurious lion's mane. Another remarkable feature is the burning golden core, within which there is a ring of star formation. It covers 2,000 light-years and takes on the main role of creating new stars. The spiral galaxy PM96 in the constellation Leo is 31 million light-years distant. Remarkably, the galaxy's nucleus is off-center. Gas and dust ignore symmetry, and the spiral arms are blurred. The arms and speckled rings of young blue stars resemble pearl necklaces. The elliptical galaxy RC105 or 3379, 32 million light-years distant in the galaxy, is also interesting. Several young stars and clusters have been found. This tells us that although the evolution process is slow, but still continues to give birth to stars. And one solar-type star appears every 10,000 years. A curious picture is brewing around FRS 105 and NGT 34-854, where a giant ring of neutral gaseous hydrogen is concentrated. It has a radius of 650,000 light-years and has zones of active star formation. The mass of the ring exceeds the solar 1.8 billion times. Such galaxies are faintly luminous, have a rounded shape and few visible objects. They also rarely show signs of recent star formation. Instead, such galaxies are dominated by ancient red stars. The constellation Leo is the most visible in the spring sky due to the necklace of bright stars that make up the giant, King of Beasts figure and many galaxies. This constellation deserves a detailed study. The cosmic estate of Leo covers an area of 497 square degrees and contains, according to various sources, up to 122 stars. The most convenient time to observe the constellation of Leo. Spring, especially its first half in March with the onset of dusk in the constellation of Leo, appears in the southeast, being quite high in the sky, halfway between the horizon and zenith. We wish you successful observations and clear skies. In ancient times, people believed that they lived on a vast flat surface, although this surface was covered with mountains and hollows. This belief persisted for many thousands of years until Aristotle, in the 4th century BC, noticed that a ship going out to sea disappears from view, not because it shrinks to an unacceptable size as it moves away, but on the contrary. First the hull of the ship disappears, then the sails, and then the masts. This led him to conclude that the Earth must be round. But what can we say about the universe? Is it even worth pondering what shape it is? Can we even determine the shape of the universe like we did with our home planet Earth? What would you see then? Endless darkness, lots of bubbles, a snow globe, or maybe a maze in your hands. Determining the shape of our universe has proven to be much more difficult than thought. For one thing, it can be infinitely distant, like the number 3, or it can have an intricate shape, or even be finite. Of course, any inferences about the possible shape of our universe must be based on real facts derived from astronomical observations. Without this, even the most beautiful and plausible hypotheses are doomed to failure. So let's see what the observational results say about the universe. First of all, let us notice that no matter where in the universe we are, around any point of the universe we can outline a sphere of arbitrary size, containing inside the space of the universe. This somewhat artificial construction tells us that the space of the universe is a three-dimensional manifold. The question immediately arises as to which variety exactly represents our universe. According to calculations, there are so many that a complete list still does not exist. But still, science does not stand still, and many years of observations have shown curious results. The universe has a number of physical properties that drastically reduce the number of possible candidates for its shape. And one of the main such properties is the topology of the universe and its curvature. Of course, finiteness does not imply that the cosmos has an edge from which one can pile up like a crowded summer star. For example, the surface of our planet, of course, but to go beyond the sphere, moving on it will not work. With the positively curved variant, we get S4, the peaceful sphere. This variety has an end, but no clear boundary is distinguished. To be precise, 2 particles would cross it before returning to the start. You can even test this at home. Take a balloon and draw a straight line until it returns to the starting point. This kind of fits into 3 dimensions and appears, if there is a huge amount of energy in space, to completely and bend or lock into space would have to stop expanding. This would occur if there is a massive energy supply that could create an edge. There is also a suggestion that the universe has the shape of a so-called 3-dimensional saddle. This form is devoid of boundaries in space and time. There is little energy. That's why the universe won't stop expanding. If you let 2 particles along the line levels, they will never meet, but will just diverge infinitely until they go in different directions like brain hemispheres. There is this understanding and the notion that the universe is flat. If it is, then a critical amount of energy will oscillate between the extremes, and after a while the expansion will stop. In such a universe, 2 particles will travel in parallel, but will never separate or meet. It is easy to visualize these 3 forms, but there are many more variations. The soccer ball is reminiscent of the spherical universe idea. Then, of course, there's the shape. The donut is technically flat, but connected at certain points. Some believe that the huge warm and cool spots found in the universe are in favor of this option. But let's go back to the beginning, the very beginning. If we take into account the Big Bang Theory, then, accordingly, there is no concept of here and there before and after. All the matter of the world was concentrated in one point and with practically zero size and, accordingly, practically infinite density. Time did not exist either, because nothing happened in the point itself, and nothing happened outside of it and, therefore, could not happen. Then, for whatever reason, the point exploded and began to expand. The newborn matter rushed with the speed of light into the surrounding nothingness. Energy and nuclear, electromagnetic, and gravitational forces appeared, and so time appeared and began to flow. In this case, it is even possible to determine the age of the universe, and it is about 15 billion years. If this is true, then the answer to the question of the size of the universe becomes clear. If it is true, the size of the universe can easily be calculated even by a cardboard toy consultant. You just need to multiply time by the speed of matter flying apart, that is, the speed of light, 300,000 kilometers per second. Most likely, this speed becomes somewhat less over the years, but for simplicity of calculation, we will consider it constant. Yes, we get a huge number with many zeros, but still not infinite. Conclusion: the universe is large, but, of course, and therefore, must have not only size, but also shape. And here is where the most interesting thing begins. It is logical and easiest to consider that the universe has the shape of a sphere. In fact, if matter is flying away from a single center at a constant speed, what can it be but a sphere? No matter how you look at it, the classical explosion implies exactly this shape. But what if the velocity is not constant and the universe is not closed and homogeneous? Then the shape becomes highly variable. For example, straight or curved. A black plane. In that case, the universe is not closed, eternal and infinite. But there's another interesting thought. The Soviet scientist Dmitry Ivanenko, back in the middle of the last century, suggested that the universe, first of all, is closed, and secondly, far from everywhere obeying the laws of the so-called Euclid. In geometry, this means that somewhere there are places where parallel lines intersect and even flow one into the other. For example, if we set out on a journey from one of its points, say, with the planet Earth, and moving, as we think, strictly in a straight line, we will eventually find ourselves there on the Earth, albeit after a very large number of years. If that's the case, then the universe is like a bottle or a pumpkin or Skittles. Something like that. Yeah, well, we've looked at a lot of shapes, but we haven't been able to determine exactly what they are. The only thing that makes us happy is that today the scientific community is trying to get information about the shape of the universe by studying the so-called relic radiation. After all, the Big Bang was accompanied by the release of not only matter, but also radiation. This electromagnetic radiation, called relic radiation, has its own unchanging physical characteristics that allow astrophysicists to distinguish it from the vast variety of other cosmic rays. It is believed that relic radiation still fills the universe uniformly. Moreover, it is now possible to measure the curvature of the observable universe. In this case, the shape is already beginning to emerge. We just need a little more time. What do you think about this? you will share your shapes. How? In the universe, we can find incredible and unexplained anomalies. We're going to talk about one of them today, and we're going to talk about the relic cold spot, also known as the super void, or 3 billion light years away from Earth. It's a very dark region. It's located in the constellation Radon. It's almost 2 billion light years across. To understand how huge the space is, you can give the example of the size of the disk of our galaxy, which is estimated at only 100,000 light years. That means that in the Rho area, it could hold 20,000 galaxies like ours. So how is it that there is nothing in this region of the universe? We don't know. No planets, no galaxies. There's just darkness and emptiness. Basically, a wasteland for new projects. If a spacecraft were to somehow find itself there, it would not be able to see, hear, or even orient itself, which makes this place even more sinister and mysterious. All we know is that there is a void at the top, or it is a giant dark area of radiation temperature that was much lower than the surrounding space. It's like finding a tennis ball-sized void in a drift of snow that has not only separated from the rest of the snow mass, but also has a much lower temperature. And there must be some explanation for this phenomenon. There must be an explanation for the super emptiness nearby. Certainly, in the universe for quite a long time are found voids where there is no substance, neither dark nor light. However, the size and radon of the universe is truly astonishing. It is 1,000 times larger than the usual voids that separate superclusters of galaxies. According to the standard model and cosmology, there should be no such region at all. How did such a relic cold spot come to be? And what interest is this anomaly to us? Let's first understand what relic radiation is in general. In simple words, it is a cosmic microwave background, invisible without special equipment. According to the Big Bang Theory, relic radiation is an attenuated echo or from close to this very explosion. The word relic itself in Latin means residual, but also has a meaning like ancient or eternal. In general, relic radiation is different from the nationality, but there are still anomalies in it. The largest of these is the super void, is transmitted. Interesting, and the fact that the average temperature and, accordingly, the general microwave's background in this area is noticeably lower. Everything else is the universe. To give specific figures, the temperatures of the void transmitted are 70 microkelvin below the average temperature of the relic radiation. This figure may seem, to put it mildly, quite insignificant, but the average temperature fluctuations of relic radiation do not exceed 18 microkelvin. And this is highly unusual since there is supposedly no matter in this cosmic void. And, of course, these unexplained things still give rise to many theories and versions. For example, there was an assumption that this area is a giant black hole and it is moving towards us and we will all die. However, it was later found out that this is impossible because even the largest of these mysterious objects, reaching, according to some estimates, hundreds of 1 billion solar masses, are very small in size. There is also a hypothesis that the entire void could have arisen near very massive objects, to which, like iron filings to a magnet, attracted all matter from neighboring regions of the universe. But this version generates only enormous confusion. Then came the theory that the relic cold spot could be the imprint of another universe beyond our own, caused by quantum entanglement between the universe before the cosmic inflation split. But even sophisticated terms couldn't save this theory. And we realize that something else is at work here. All we have is time. And with it, we have new data to help us discover what's hiding the largest individual structure in the universe that man has ever observed. So, let's start with the fact that not long ago, a map of relic radiation and the supervoid of radon was made. This was possible thanks to a database of space observatories and telescopes. The information obtained was enough to build a three-dimensional map of the cold spot, on the basis of which there was evidence that the supervoid and radon may represent the largest in the universe area of space free of galaxies, quasars, their clusters and stars. However, the void is not an absolute void, but a region in which the average density of matter is half or perhaps a third of the average density of the surrounding white space. The peculiarity of this assumption is that the more empty a region of space is, as in the case of a relic spot, the less matter it contains to slow down the expansion. Thus, the rate of local expansion is twice that of the surrounding regions. Hence the difference in temperature and external background. This explanation looks very reasonable, but on the other hand, it raises more questions than answers. First, the largest known HAL has a length of 489 million light-years. Secondly, it remains quite unclear how a void of this size could have arisen. And finally, why it was not at least partially filled over time. After all, according to the Big Bang Theory, dark energy expands the universe, thereby accelerating it. However, this did not happen in the case of the supervoid of radon. The question is why? And here we come to another curious theory. What if there is no dark energy at all? After all, according to the observations that allowed astronomers to conclude its existence, we can also assume that our galaxy lies at the center of a giant cosmic void and the uneven expansion of space caused by variations in the density of matter on grand scales may be generating an effect that is known as dark energy. But the theory doesn't end there. It's just gaining momentum. A local group of galaxies, which includes the Milky Way, is believed to be at the center of the largest known void in the universe. This fact helps explain why the expansion rate of the universe turns out to be different when it is measured by different methods. We also know that there are dense clusters of galaxies in the universe and voids almost devoid of galaxies. As the calculations suggest, the void at the center of which we are located is the largest of all the voids in the universe that have been discovered. Its diameter is 7 times the average radius of the universe's voids and is about 1 quadrillion light-years across. Perhaps the most interesting conclusion from our galactic loneliness comes down to the fact that perhaps the universe is not expanding at an accelerating rate, and therefore the dark energy hypothesis is not needed to explain this acceleration either. Be sure to share what you think of this unusual but noteworthy theory. Or perhaps you have your own ideas regarding the origin of the spheres of emptiness. Past. It will be interesting to hear what you think as well. What's the bottom line? The new details have raised even more questions and theories. Guesses and assumptions continues to add to the list. Only a more careful and prolonged observation of the section of the starry sky in the area of constellations will allow us to understand what we are dealing with. But the fact remains that the void has been passed over. This is the most mysterious part of the universe, to comprehend the mysteries of which will take a lot of effort and time. The supermassive black hole that lurks at the heart of most galaxies is often described as a monster beast or huge palm trees devouring the matter around it. And indeed, so-called black holes reach enormous sizes. But despite this, they are almost invisible. To see if they are there at all, you have to measure the speed of the clouds of gas swirling around these regions. Fortunately, it is sometimes possible to recognize their presence thanks to the creation of powerful jets of plasma. These phenomena manifest themselves in different ways and say a lot about their source. However, there are also some very unusual anomalies that are probably evidence of the confirmation of such a theory as horizon skin. What it is and how it affects time, we will certainly discuss. But before we do, let's remember what we already know about these phenomena. Today, we already know that jets are two streams of plasma consisting of electrically charged particles moving in opposite directions, with speeds very close to the speed of light. The jets emerge from a region the size of the event horizon, supermassive black holes, and spread out far enough to escape from their galaxy while maintaining their shape for long periods of time. This corresponds to a length that is 1 quadrillion times their original radius. To illustrate, here's an example. Imagine a hyper-fantastic water fountain. There's a hole in the center that's only 1 centimeter wide, and out of it comes a jet of water 10,000 kilometers high. That's what the power of mysterious objects like a black hole can do. Over time, as the jet spreads over great distances, they lose their former stability and are prone to collapse. The disintegration manifests itself as a dashed line. One thing can be concluded from all of the above. Plasma jets are a relatively normal phenomenon in deep space. They burst from the center of the nuclei of astronomical objects such as black holes, active galaxies, quasar, and radio galaxies. What we can see, we can see. The point is that not so long ago, something similar to jets was discovered, and yet something else. So, the center of our galaxy is shrouded in dense clusters of gas and dust, through which the radio emission of a bright Sagittarius object shines through. It's believed to be a supermassive black hole with a mass of 4 billion solar masses. Near it was found a very narrow thread of some kind of substance, extending itself to the black hole, a curved symbol. The thread is record-breakingly close to the black hole. Most likely, it has nothing to do with the construction site. Of course, it's possible that the latter is just a seeming effect. I mean, we can look at the sun through our fingers. This does not mean that the star is in our hand or mains. In general, a number of subtle image details lead researchers to believe that does not really lie in the immediate vicinity. According to the latest calculations, the distance ranges from 0.8 to 2.4 light-years, and the filament itself is 3.2 light-years long. At the same time, given the speed of light in a vacuum, we can calculate that a light-year is about 9.5 trillion kilometers. Do not forget to multiply this by 3, and we get almost eternal wandering along this thread. But let's not be sad. And let's get back to the origin of this phenomenon. So far, we have as many as 4 hypotheses. One is that the supermassive black hole and the filament are not connected at all. Second, the filament may consist of fast particles ejected by the black hole. If the hot plasmas around it have a powerful magnetic field in which the particles circulate, accelerated almost to light speeds. In some galaxies, jets of matter are ejected from such disks, which we discussed above. However, how the filament acquired a curved shape, it remains unclear. The third, much less likely hypothesis suggests that the filament was formed by the space country of a hypothetical eponymous fold of spacetime, which is moving toward the center of the galaxy and will soon be captured. Supermassive black holes. According to some calculations, it follows that the filament must be moving as a single unit at a speed comparable to the speed of light. The fourth assumption does not tell us the origin of the filament, but tells us what is happening to it right now. Namely, the curved, narrow filament goes beyond the event horizon of supermassive black holes. This is also evidenced by some of the analyses of this area, which means that, thanks to this filament, we can witness what is actually happening beyond the black hole boundary. So why wait? Let's do it right now. For this, as always, we need a sacrifice. It's up to each of us to decide who are willing to send on an exciting, albeit futile, journey. I've already chosen, so let's get started. It's believed to be a rather enormous black hole. Our subject could probably survive not only a passage through the event horizon, but also a collision and subsequent passage through the Cauchy horizon. What is a Cauchy horizon? The Cauchy horizon in a black hole is a thin boundary, probably deeper than the event horizon, but still far from the center of the black hole singularity. At this theoretical location, the gravitational force reaches a point where time is no longer just slowed down, but simply stopped. The boundary between events becomes zero. That is, past, present, and future merge into one infinite-skinned instant. From this, it suggests that everything falling into a black hole falls at a single moment in time. Look up at the night sky from a place with a good view, and you will see a thick band of the Milky Way, stretching a highway across the entire sky. And although these stars and nebulae are incredibly beautiful, it is still a hindrance to those who study other galaxies far beyond our vast and mysterious regions in the depths of space, which for many decades astronomers have been trying to discern. These places are commonly referred to as the avoidance zone. Thus, in the late 1920s, Harlow and his colleagues began investigating galaxies in the southern hemisphere of the sky using plate photographs obtained with a 60-centimeter telescope in South Africa. By 1932, Chappell reported the discovery of 76,000 galaxies brighter than 18 visible stellar magnitudes in a region occupying one-third of the southern hemisphere. In 1930, Chappell published a note on the observation of a distant cloud of galaxies in the constellation Centaurus. He wrote the following: "The cloud of galaxies of the center is so large that it may be one of the most densely populated of its kind, and has yet to be discovered." In 1989, the cluster of spikes was recognized officially with the Schmidt telescope in the UK. In this paper, the Bohemian Pliny, and was named after Harlow in recognition for his services to the study of galaxies in the supercluster. So what is it all about? Why is the light of the cluster called an archipelago of galaxies, and why is it so? These questions have interested many astronomers, and for good reason, because it is not just an object in space. The light of the cluster represents something more. Efforts have been made to reconcile two contradictory facts. On the one hand, in the early cosmological epoch, matter filled space in an extremely homogeneous manner, as evidenced by the highest of the relic microwave radiation passing to us on Earth as a messenger of that epoch. On the other hand, in our present-day universe, matter is distributed extremely inhomogeneously. It is collected in stars, galaxies, and galaxy clusters, forming a hierarchy of gravitationally bound objects. To reconcile these two facts, it was necessary to understand how a very complex observable structure of the universe could be formed from almost homogeneous matter. What forces played a determining role in this process? After all, we know that the Milky Way, like all galaxies and the cosmos, moves. Everything in the universe is constantly moving. That is why there appeared such a concept called speculative velocity. This is a separate flow that involves you and me as well. A local group of galaxies that includes the Milky Way, Andromeda, and a few dozen other small objects, moving at about 600 kilometers per second relative to the residual radiation. But, as is usually the case, one mystery was replaced by another. For example, it turned out that not everything has a constant speed, that something moves faster and something slower. Somewhere clusters form, somewhere great voids form. But why has everything that could be pulling and pushing a local cluster been counted over the past few decades? Nearby clusters of star galaxies, clusters of wall, clusters of wall, clusters of clusters, and cosmic voids exerting a gravitational influence on our group that cannot be ignored. Fortunately, in time, X-ray astronomy came to the rescue and developed enough to allow us to look beyond the avoidance zone and find out what was causing such a strong gravitational field. What we saw turned out to be an ordinary cluster of galaxies. This raised even more questions, as these galaxies could not be the Great Tractor and have enough gravity to attract outside our Milky Way. But time has passed and new technology has allowed us to see that the Great Cosmic Magnet is a much larger object than the Great Tractor. That object is the supercluster Spike, the largest tug with a mass of 50 million billion solar, located on a celestial sphere not far from the cluster of sails, and sits about 650 million light-years away from us. It has an elongated oval shape with an angular diameter several times the size of the lunar disk. At the moment, the contribution to the velocity of the local group from the Great Tractor is estimated at 44%. The remainder is due to the global current, where a significant portion of the local universe, including the Great Tractor itself, is moving toward an even stronger center of gravity located near the cluster, which represents the increased density of the distribution of galaxies in the constellation Centauri. It contains about 10,000 times the mass of the Milky Way and 4 times the mass observed in the region of the Great Tractor. And that's beyond staggering. But we were able to look even further. It turns out that at the center of this region is a very rich cluster of galaxies called N8. It's important to say that this region of the sky, which has a declination of about 30 degrees, is very difficult to study. Therefore, information about its distant galaxies in this region of the sky has been accumulated very slowly. However, in recent years, with the help of several huge telescopes, astronomers have measured the coordinates and velocities of several 1,000 galaxies in the same area and were finally able to study their location in space and mutual motion. In the end, it turned out that the astronomer was right. In the direction of the constellation Centaurus near its boundary in the constellation Hydra, there is a giant seal of matter which collected many clusters of galaxies and individual star systems. Various researchers have called it the Centaurus Alpha Cluster region, but have recently settled on the name Light Cluster Sizzles. The task was set to determine the mass of this giant supergalactic structure. It would seem a seemingly simple task with modern technology. After all, it is enough to count the number of galaxies in the cluster and multiply their number by the mass of a typical galaxy. But this method does not work here, because besides galaxies in the cluster there is also invisible intergalactic matter, and in quantity more than concentrated in galaxies, and the full mass of the cluster can be judged only by the strength of its gravitation. But how then to estimate it? According to Newton's second law, the force acting on a galaxy is proportional to its acceleration. But we've only learned to measure the velocity of galaxies. Sometimes, however, it's enough to know only the velocity. For example, the speed of a satellite around the Earth and the radius of its orbit give us enough data to calculate the mass of the planet. But that's only if the satellite is traveling in a stationary orbit. If a cluster of stars has reached a stationary state, then by the velocities of individual stars, we can judge the total mass of their cluster. The same is true for a cluster of galaxies. However, this method of clustering could not be applied because the largest structures of the universe have not yet reached a stationary state, and this huge but still not dense enough area still continues its expansion, although not so fast, supercluster, so huge that it has a powerful attraction, is able to attract to itself not only 1,000 galaxies, along with our own, but also the Great Tractor itself. The scale is so colossal that it's hard to imagine. And subconsciously we realize that if a huge supercluster of spikes has been discovered behind the Great Tractor, then what must be beyond it? Yes, the more we unlock the mysteries of the universe, the more we come to realize that we have so little about it. Knowledge. Our planet Earth is but a tiny speck of dust in the universe. Its average diameter is 12,742 kilometers. We, people, accustomed to measure distances in meters and kilometers, it is quite difficult to realize the global scale of the entire universe within the solar system. For convenience, use a unit of measurement of astronomical units equal to 150 million kilometers, or the distance from the Earth to the Sun. The distance from our luminary to the dwarf planet Pluto, which is at the back of the solar system, is equal to an average of 40 astronomical units, or almost 6 billion kilometers. But in outer space distances are inexpressibly large, so for convenience use such a unit of measurement as the light year, and the distance that light travels in a vacuum in 1 year. For example, light from the same Pluto to the Earth goes 5.5 hours, that is, and the distance to it is 5.5 light hours. But the distance to the nearest star to us, Centauri, is 4.2 light-years. To the nearest large galaxy in our local group, the Andromeda Galaxy, is 2.5 million light-years away. But even that's still a bit far. Today we're going to go much further, exploring the large-scale structure of the universe. In cosmology, this refers to the structure of the distribution of matter in the universe on the largest, observable scales. But before that, we've landed on Earth in Russia, the Republic of Tatarstan, and we'll take a peek into a company where both students and employees are truly valued. What it's all about. And a large number of flares means a high concentration of matter, and thus the presence of a large number of galaxies. Analyzing the distribution of galaxies and their velocities led to the conclusion that superclusters cannot be considered as the same stellar systems as the clusters themselves, only larger-scale superclusters. As it turned out, these are not isolated islands from clusters or from separate galaxies, but simply the most dense areas and fibers of pure structure formed in space by galaxies and their systems. Some analog of such structure can be the foam from soap bubbles. True, the distribution of galaxies along the cell walls, unlike the distribution of soap solution in a bubble, is very inhomogeneous, and the cells themselves do not have regularity of shape. The sizes of the larger cells are several tens of mega orders of magnitude or hundreds of 1 trillion light-years, but there are many smaller ones. The shape and size of clusters in outer space can vary from small chains such as the Markarian chain, a few galaxies and virgin clusters to walls such as, for example, the Great Wall, as if on the scale of the order of 300 megapeaches. The universe is virtually homogeneous and is a collection of meteoric clusters of galaxies separated by regions with virtually no matter. These regions of emptiness or water are on the order of 100 megapeaches in size. In such areas, the density of galaxies is at least 10 times less than average. Some voids can form extended, relatively flat local structures that have been called walls. The first such observed super-large-scale object was the Great Wall II, located 200 million light-years away and having an incredible size of about 500 million light-years long and only 15 million light-years thick. The enormous group of quasars is 4 billion light-years in size. The open Great Wall of Hercules. The northern corona is over 10 billion light-years or 3 megapeaches in size. This huge flat superstructure of galaxies is about 10% of the diameter of the observable universe. But the nearest such wall to us passes through the southern constellations Hydra Centauri of the Peacock and Indian Telescope. The galaxies that form it have a radial velocity of several 1,000 kilometers per second, and most of them are at least 25 million light-years away from us. The Virgo cluster and all the local supercluster belong to this wall, with a local group of galaxies on its periphery that includes our Milky Way. Since we are near the edge of this wall, the constituent galaxies form a relatively narrow band in the sky, stretching themselves over 180 degrees, similar to the way the stars of the galaxy concentrate for us, into the band of the Milky Way in the sky. It is important to realize that the universe can only be considered homogeneous starting at a scale of a few 101 billion light-years. For example, a cube of that size or larger, wherever it is placed, will contain roughly the same number of galaxies, clusters of galaxies, or votives. On smaller scales, the distribution of galaxies cannot be considered homogeneous even approximately. This important conclusion has to be taken into account when developing a cosmological theory of the evolution of the universe. The analysis of the generated three-dimensional model of galaxy distribution suggests that the pure structure is also observed at a distance of more than 1 trillion light-years in any direction. This information suggests that on a scale of a few 101 quadrillion light-years, any fragment of the universe will have almost the same amount of matter. This is what proves that at these scales the observed universe is homogeneous. Despite the presence of large-scale structures such as the galactic wall and filament, the largest stable structures are still considered to be clusters of galaxies. The fact is that the known expansion of the universe gradually stretches the structure of any objects, and only gravity can fight this force. As a result of observations of the cluster and superclusters was found such an effect as gravitational investment, that is, the rays passing through the interstellar space and are fixed, indicating the presence of a huge, invisible, hidden mass in it. It may belong to various unobservable cosmic bodies, but at this scale, most likely belongs to dark matter, which is responsible for the attraction and holding galaxies together and the formation of their clusters. The nature of the same mysterious dark mass is still being clarified, considered several possible variants of elementary particles of which it consists. But it is already obvious that this invisible medium plays a major role in the formation of large-scale structures of the universe without the involvement of dark matter. It would be very difficult to explain how, in 13-14 billion years, the expansion processes, barely capturing the density and homogeneities captured in the brightness distribution of the background radiation, were able to grow so large as to produce the observed complex structure of the galaxies formed. A world of stars and galaxies apparently could not have arisen at all, and the universe would have been left without structure. If the gravitational field of ordinary matter had not been enhanced by the presence of no luminous hidden mass, relying on nearly uniform relic radiation, researchers are convinced that the matter in the universe is evenly distributed, but the peculiarity of gravity is that it tends to envelope any physical particles into dense structures, thereby breaking homogeneity. Thus, sometime after the Big Bang, minor inhomogeneities in the distribution of matter in space became increasingly constricted into certain structures due to the increase in mass and gradually slowed down the expansion until it stopped altogether. Not only that, in some parts of the expansion turned into compression, which was the reason for the formation of galaxies. Galaxy clusters and the very large-scale structure of the universe in the form of a three-dimensional cosmic web and voids between the threads of this web. Research in recent years has led to the conclusion that the rich picture of modern cosmic structure emerged in the first moments of creation after the Big Bang, when the faint 14 billion years of evolution were superimposed on a homogeneous and rapidly expanding primary broth. This was amplified to enormous proportions by gravitational forces, creating an ever-growing and concentrated dark matter in which ordinary gases cooled, condensed, and fragmented to form galaxies. This process can be accurately reproduced in large computer simulations. The modern theory of the formation of large-scale structure, as well as, indeed, individual galaxies, is called the hierarchical theory. The essence of it boils down to the following: yes, on a very large scale of observations, the universe should be homogeneous and isotopic, random. Fluctuations in the mass and structure of matter between different regions of the universe should be very small. According to current understanding, the scale at which homogeneity should manifest itself is about 300 million light-years. This is the so-called apogee of greatness. No inhomogeneous structures of larger dimensions should exist. However, the huge walls detected are 1 sextillion light-years larger than the predicted scale. The Hercules Wall northern corona inhomogeneous structure measuring more than 30 times the predicted scale. Of course, this calls into question the cosmology principle itself. Furthermore, a distance of 10 billion light-years means that we are observing this structure as it was 10 billion years ago, or 3.7 billion years after the Big Bang. The current standard model of the evolution of the universe does not allow for the formation of such complex and massive structures at this stage. There are no hypotheses yet as to how such a large structure could have formed in a relatively short time. Thus, the study of the large-scale structure of the universe is a necessary link, without which it is difficult to understand how the world around us came to be. 9 such gamma-ray bursts, stretching over 5 billion light-years. The likelihood that this is any kind of coincidence is slim to none. But we can't rule it out. The gamma-ray bursts that make up the newly discovered ring have been observed from space and from ground-based observatories. They appear to be at a very similar distance from us of about 7 billion light-years, in a circle 36 degrees across the sky, or more than 70 times the diameter of the full moon. This means that a ring more than 5 billion light-years across is only 1 in 20,000 probabilities of gamma-ray bursts being in that distribution. Quite by chance, most current models show that the structure of the cosmos is uniform on large scales. Other recent results and this new discovery challenge the principle that sets a theoretical limit of 1.2 billion light-years. For the largest structures, if the ring is a real spatial structure, it should be visible to the almost naked eye because of small changes in distance. Gamma-ray bursts around the center of the object. The ring can be thought of as a projection of the sphere where all these gamma-ray bursts occurred long ago within 250 million years. A short time frame compared to the age of the universe. So how could such a structure have formed? Researchers are considering 2 explanations for what the observed objects look like. In the simplest case, the galaxies could be roughly in the same plane, thus forming a single ring. This would mean that it is oriented almost perpendicular to the direction of the Earth observer's gaze. Another explanation suggests that this structure may not be a flat real object, but some projection of a sphere onto the plane of the sky. The random is located on the sphere. The points would preferentially cluster near the edges of the projection circle, creating the illusion of a ring. The existence of a cluster of this size may contradict existing cosmological principles. Gamma of the universe. An earlier study by the Planck and WU instruments set a limit on the size of cosmic objects at 1.2 billion light-years. This is the order of magnitude that would severely disrupt the existence of the notion of homogeneity based on observations in the microwave range. If the author's findings are confirmed, astronomers may have to reconsider existing constraints on the evolution of the universe. The first example of such giant formations was the discovery of a cluster of quasars in 1982. Its size was about 350 million light-years. However, larger but unstructured objects were subsequently discovered. The Great Wall of Hercules, which seems to extend over 1.37 billion light-years, and the Great Wall of Hercules' northern corona, which stretches over 10 billion light-years, about 10% of the observable universe. These flat formations are made up of alternating cavities and clusters of galaxies. Who knows what we'll discover tomorrow? Yes, the universe never ceases to amaze. We're going to try to get close to this giant and get to know it a little bit better. It won't be easy, as the star is nearly 20,000 light-years away from us in the constellation Scoto. The star Stephenson 2F18 is so huge that it becomes out of competition in size among other stars. When has any of them ever been discovered? The giant massive ball of gas is actually a red hypergiant, a star of immense mass and size. Hypergiants are defined as the most powerful, heaviest, brightest, and also the rarest and shortest lived overhead giant. The mass of a hypergiant far exceeds that of any star, even a supergiant. For example, a typical hypergiant is 6 times more massive than a powerful star like Rigi. The typical mass of a hypergiant is 120 solar masses or more, up to 250 solar masses. The most massive known so far is thought to be 1361, having 265 solar masses. In size, hypergiants are no more than spheres of giants, but their masses are much larger, so they are approaching the theoretical mass limit, which is critical, on the verge of transition to the formation of a black hole and extremely unstable. The luminosity of hypergiants can exceed 500,000 of the Sun's luminosity, and sometimes it is 1 million of the Sun's luminosity as well. These stars have extremely short lifespans. Thus, the lifespan of a hypergiant is on average 1 at most a few 1 million years. The reason for this is that because of its enormous mass, a hypergiant must generate enormous pressure to compensate for gravitational forces. Whatever the observatories are looking for, such massive stars are very rare in our galaxy. There are only about a dozen or so hypergiants. We now know a little bit about what kind of stellar dough the star is made of. Stephenson 218. For the record, the star, as it turns out, was not easy to find. It was discovered in the JC2 star cluster, which is located in the constellation Scoto. In this area was confirmed 26 red giants, which are representatives of the cluster. Moreover, this number exceeds the population of supergiants of other clusters. A recent study allowed to detect about 80 red giants. About 40 of them have the best speeds, comparable to the speeds of the objects of the cluster. The cluster is estimated to be between 14 and 20 million years old. The observed red giants with masses of about 12 to 16 and solar masses are precursor stars of Type II supernova explosions. The clusters are largely obscured by dust and are not observable in visible light. But as we can see, not everything is hidden from the gaze of astronomers. It is in this cosmic zoo that our prize hypergiant was discovered, Stephenson 218. It is now known to be the largest star discovered and one of the brightest supergiants with a radius 2,150 times the radius of the Sun and a volume that would put about 10 billion suns inside it. It's such a huge star that it's mind-boggling. So what else do we know about this giant? Current models of stellar evolution predict that Stephenson 218 is already thermonuclear, burning helium in its core. At the same time, hydrogen burning continues in the core shell when the fuel for thermonuclear reactions in the star finally runs out. The biggest giant ever found explodes as a Type II supernova. This is a category of supernovae stars, which in turn is subcategorized by cataclysmic variable stars. The explosion will leave behind a nebula with a neutron star at its center. Although some believe that the star Stephenson 218 brightest representative of a black hole, after the explosion, what size the hole will turn out to be, it is difficult to say. Unfortunately, because the star is so far from our Earth, it cannot be observed because it is too dim despite its size. Nevertheless, the existence of these stars seems enough to give us an idea of how small our Earth is, how tiny we are in a universe that is bigger than we can imagine. Pulling as far out as we can. Looking at the night sky, the stars and galaxies seem to be arranged more or less randomly. However, this is not entirely true. Despite the chaotic nature of the universe, it's not a random jumble of objects. It's full of stars literally right at our fingertips. But if you travel more than 100,000 light years, you leave the Milky Way. Beyond it will be a sea of galaxies, perhaps 2 trillion galaxies. In total, they can already be found in our observable universe. They come in a great variety of types, shapes, sizes, and masses. However, in addition to galaxies, there are nebulae, star clusters, clusters of galaxies, and even superclusters of galaxies in the vastness of space. Some such objects in the observable universe have been singled out by astronomers as large-scale structures because of their incredibly large size. The largest of them span hundreds or even 1 quadrillion light years because of their elongated shape. These objects have been called galactic filaments. These filaments intertwine with each other and fill empty outer space, as if forming a 3-dimensional web. But that's not all. Water and galactic filaments can form great walls, but what are they? Walls in the universe are commonly thought of as a flat structure of galaxies and voids, the third largest known such structure in the universe. For example, Great Wall 2 was discovered in 1989 based on data from redshift studies of distant objects. It is the third largest observed large-scale structure in the universe. These objects are a flat structure of filaments of prominent galaxy clusters surrounded by a void. The voids are thought to be filled with dark matter, which determines the structure of the universe on the largest scales. The object is about 200 million light years away from the Milky Way and is 500 million light years long, 300 million wide, and 15 million light years thick. However, the exact size of this object has not yet been determined, as clouds of dust and gas from the Milky Way obscure part of this Great Wall from us. Next, we look at the Great Wall as if it were a complex of superclusters of galaxies extending over 1 quadrillion light years. It is a flat structure of galaxies and voids. The wall is 1.37 billion light-years long. It is located approximately 1.2 billion light-years from Earth. The Great Wall is like 2.74 times larger than the two previous record holders in terms of length. The discovery of the Great Wall was announced on October 20th, 2003. This discovery was made thanks to the data of Digital Celestial Survey (CDCBC). It is hard to imagine how big our universe is. Another example of this is a cosmic object located 6.8 billion light-years away from the solar system. The first place is the Great Galactic Wall, called BOSS, as astrophysicists later named it, has a length of about 1 billion light-years. Researchers believe that the found object is more than half the mass of the previous record holder, over a cluster of galaxies of a layout that includes our Milky Way galaxy. When we look up at the night sky, we might get the impression that the stars are endlessly scattered throughout space in an evenly spaced manner. But it is known that this is not the case. Stars are gathered in galaxies, and galaxies are grouped together to form gravitationally star clusters. In general, the situation is such that neighboring galaxies are relatively close together, and the void does not extend over very large areas and spaces. But there are special cases, such as the property of bursting. This incredibly sized region of empty space is 7 million light-years away from us, but its diameter is even more astounding. It's estimated at 330 million light-years. The Great Void for almost 40 years has amazed with its size and properties, forcing the most unusual hypotheses about its nature. But before we delve into the void, in the sense of not being depressing, we'll take a look at the constellation in which it is located. There was a constellation? It was recorded in the 2nd century of Ptolemy. It got its name from a Greek word meaning plowman or shepherd. It's located in the northern hemisphere and is one of the largest constellations in the sky. If we are to travel to the Great Void, we will encounter several notable stars along the way. Let's consider them by distance. The closest and most special of these is, of course, the star Arthur. The orange giant is the 3rd brightest in the sky, the brightest in the northern hemisphere. From us is almost 36 light-years away with a luminosity 110 times that of the Sun, moving at 122 kilometers per second relative to the solar system. It will come closest to the Sun in about 4,000 years. Star Manfred spectroscopy check double star with a period of 494 days. Both stars are located at nearly the same distance from the Sun, approximately 37 light-years. One of the stars, Frid, belongs to the Genoa class. It has a surface temperature and color similar to the Sun. Frid is a subgiant. The star is on its way to becoming a red giant. As we continue on our way, we will see the stalk at JG 51 light-year. The double star is represented by a yellow-white dwarf and a dim red dwarf. Next, the No Ceres star is located 85 light-years away. It's a variable delta shield type star, showing changes in brightness due to radial and non-radial pulsations on the surface. Robson's star is not a Kear at all, but a triple star 121 light-years away. Then we trace a star called Robson's star. A yellow giant of the same type is already 219 light-years away, It's a flaring variable star that increases in brightness for a few minutes. A brazen orange giant-type star is 250 light-years distant and a double star at 300 light-years, represented by a bright orange giant and a smaller, fainter star, the main after apart, and many other stars, rapidly approaching the Great Void, are dangerous. We note that there are other voids, though modest in size. We know today that this is the largest formation in the structure of the universe and that they occupy most of its space. According to some estimates, this share reaches 50%. And due to gravity, this percentage will increase due to the attraction of surrounding matter. Determine the presence of a void can be determined by the low density of ordinary matter. Such small voids most often contain neither galaxies nor stars. However, the interior space is still filled with some content. What is it? The voids contain products of the galactic cloud of dust and gas, which later form galaxies. And the rest is still only speculation, based on the fact that light passing through enters and refracts. The reason may be the presence of some dark matter that does not have its own electromagnetic field. And if this is so, it is not yet possible to carry out investigations with the methods known to science. We have only indirect evidence of the existence of this matter. At present, the study of voids is of great interest to you and me physicists and professors. But now a special case known as the property of bursting is attracting our attention. If we wanted to see what's inside, we'd probably have to contemplate a deep black color. And that's an intimidating, dull one. They discovered this region of emptiness quite a long time ago, almost 40 years ago, in 1983. And it was Robert Kirchner who did it. Since then, there have been many theories that this is the site of the Big Bang, that it's a super black hole, bursting and all around, that this is the territory of the priests, or that they just haven't dipped into the textures. But we do know that this region exists in the form of a sphere. And the main thing is that in this area there are still galaxies, just very few of them. First of all, the researchers were interested in how many galaxies are in this void. If initially there were only 8, then for a long time of study found 60. But even that is incredibly small. If our galaxy were at the center of this void, we would have learned that there are other galaxies. Only 60 years ago. If you compare our Milky Way, it has over 20 neighbors in a region of 3 million light-years. If we compare the average density of galaxies in the universe, there should have been 10,000 galaxies in the void, but there are only 60. Certainly visitors to the area would be stunned by such isolation, to say the least. Given the extreme distance between galaxies and the view of distant space that would look blacker than black. Moreover, there would be probably the most perfect vacuum in space, the effects of which would also be worth looking at. Not only rocks and dust, but also particles of all kinds would rarely be found in it. It could take eons for particles to interact in this vast void, if at all. The extremely low density of matter in this region of space means that if some neutrino structure enters it on one side, for example, it will look exactly the same on the way out hundreds of 1 million years later. The same goes for photons. Particles of matter of much greater mass than neutrinos and photons will be naturally attracted to the edges of the void. Because of this property of the conservation of the state of the void, Laplace could one day be seen as a perfect time capsule. Be that as it may, the discovery of the supervoid had a profound effect on traditional cosmological thinking. Since then, the scientific community has repeatedly revised its understanding of galaxy formation. Given what is known about the highly uneven distribution of matter in the universe, but how could this have happened? How could such a super-huge void have formed? The small regions may have appeared because gravity brought the galaxies closer together. But how do you explain the larger regions? No one knows. Yet attempts to find an explanation have led to the development of a new theory suggesting that supervoids are formed by the merging of smaller voids, like bee honeycombs. It's also interesting that galaxies in the void take on curiously shaped tube-like structures. And this does not seem to be an accident, but an important detail. In addition, will probably form after smaller voids merge, similar to the way soap bubbles merge into one big bubble. As for tubular galaxies, they are likely remnants of boundaries between smaller ones. Void. But how true this assumption is, only time will tell. Mars, the fourth farthest from the Sun, and the seventh largest planet in the solar system. We saw the unique landscape of Mars, the Martian extinct volcano Olympus, which is the highest mountain on the planet, the Marin Valley, the largest known canyon, and a huge number of impact craters. Mars has a rotation period and the change of seasons similar to Earth's. And yet you can't relax under palm trees, which are not there. The average temperature on Mars is minus 40 degrees Celsius. Under the most favorable conditions in summer on the daytime half of the planet, the air warms up to 20 degrees Celsius. On the winter, night temperature can reach minus 125 degrees, and at the poles and at all minus 170 degrees. And yet dozens of automatic interplanetary stations and rovers were sent to Mars. To this day, we receive a huge amount of data, some of which we want to share with you. In front of you are white clouds that periodically appear in the upper atmosphere of Mars. As we know, clouds, they form on their own. For them to form, you need something to help water condense. For a long time, climate models simply couldn't explain how they could form at such an altitude. The recipe consists of so-called meteor smoke, whose burned remains help water vapor condense and turn into small moles. This discovery pushes the idea that the fine dust that arises in the atmosphere after the meteor smoke cools down may be involved in the birth of Martian bright clouds, similar to how luminous silvery clouds arise in Earth's sphere. What is interesting is that the appearance of clouds in the Mars computer model has affected the planet's weather and climate, as well as the behavior of the circumpolar regions of its atmosphere in highly unusual ways. For example, their disappearance or appearance can lower or raise the air temperature by 10 degrees Celsius or even higher values, as well as dramatically change the height of the air layer of Mars in the vicinity of its poles. Attracts attention another interesting study analysis of 200 intersecting channels showed that deep and wide rivers existed on the surface of Mars for an unexpectedly long time. In fact, oceans of water existed on Mars, containing almost as much liquid as our Arctic Ocean. This makes the story of the disappearance of water quite inexplicable and mysterious. On the other hand, part of the planet believes that even in ancient eras, Mars may have been too cold and dry to form oceans. Other researchers suggest that there was water on it, but it could be in a liquid state only in times of volcanic eruptions or after the fall of large belt asteroids. In any case, all these parameters reflect what climatic processes fed these bodies of water and how constant and stable these rivers were. The fact is that large volumes of water could pass through these channels only if the climate of Mars at the time of their existence was warm enough for both snow and rain formation, as was possible without a dense atmosphere and large amounts of greenhouse gases. It's hard to say just yet. Another interesting discovery has been the red planet's glaciers, which do not stand still, but move down the mountainsides and plains, retreating and advancing as the temperature rises or falls. These movements of the ice do not pass without a trace on the surface of the planets. Very specific landforms such as fjords, vines, and other objects appear on it, clearly indicating that a glacier once existed here. It's worth drawing our attention to something else very interesting about the so-called sand spiders of Mars. Of course not. They won't snack on settlers. They're not like that. But we do know something for sure. Mars, like Earth, has its own weather, wind system, and climate. And these canyon spiders, as observations have shown, have steadily increased in size. So what makes them grow? In fact, Martian sand dunes and deposits of dry ice, the frozen carbon dioxide that covers the velvet, are involved in the birth of these landforms. In summer and spring, when air and soil temperatures on Mars rise dramatically, some of the ice forms and melts. Thus, the dry ice turns into carbon dioxide, and a giant bubble of the gas is created under the surface of the glacier, and the pressure in it rises. After a while, it reaches a critical point. The ice bursts and CO2 escapes into the atmosphere of Mars through the cracks. Together with the gas on the surface of the ice and the dust covering it, a gigantic amount of sand enters, which, thanks to the high pressure, turns this air geyser into a kind of slender machine separating the surface. So the cracks through which the gas escapes grow each season and turn into those very same giant spiders. It's hard to realize that 4 billion years ago, Mars was probably Earth-like, meaning that its vast expanse was probably flooded with a shallow water ocean, maybe a few hundred meters deep, not kilometers deep like on Earth. But there was certainly water there. There is no doubt about that anymore. However, 1 trillion years passed and Mars was dying, lagging behind and losing almost all of its atmosphere. 2 climbers stand triumphantly on the summit of the Olympus of Mars, which is 26,000 meters high. After a long journey and tremendous effort, they have achieved what they have dreamed of since humans first set foot on Mars. Is climbing the Martian Olympus really possible? If so, how long would such an expedition take? What dangers await the travelers? And will it really be the most difficult ascent in the history of mankind? In order to test this, let's remember the highest mountain here on Earth. We are talking about Jamalu, better known as Everest. It is 8,848 meters above sea level. Everest has been climbed 9,159 times over the years. During the Everest expedition, 308 people died. The main causes of death were avalanches, falls and injuries, altitude sickness, frostbite, sun exposure, and other health problems caused by the peculiarities of climbing. At this altitude, can we expect a similar scenario on Mount Olympus? For this, let's mentally transport ourselves back to Mars again, to our expedition just at the very beginning, and be a part of it. So, Mount Olympus on Mars is the largest volcano known in the solar system. Its height from the base is more than 26 kilometers, and its width is 540 kilometers. The volcano is visible even from the ground. Before the first space satellite missions, the place on Mars where Olympus stands was known as the Snows of Olympus. The volcano reflects sunlight better and looks like a white spot from a great distance. It appeared during the Diamond period of the period when Mars stopped being attacked by massive amounts of meteorites and became the dry, cold planet we see now. Even though we are comparing Everest to the Martian Mount Olympus, we must realize that they are absolutely two amazing but still radically different places. Everest is a completely different kind of mountain. All routes involve varying degrees of difficult climbing. Mount Olympus, on the other hand, is a kind of Martian pie the size of France. And in fact, unlike Everest, the slope of the summit of Mount Olympus is so insignificant that you may not feel that you are on the mountain. And given the gravity of the planet, it will seem very easy, since we are talking about only 5% of the ascent. It's more like a walk that will take 70% of the entire climb. And even though you'll have the monotonous horizon of an essentially flat mountain in front of you, will you ever make it to Calderon? Probably the most amazing thing on Mount Olympus. There it will be more interesting, because throughout the circumference you will be waiting and a number of rocks from 4 to 6 kilometers high. This is where you'll need equipment, climbing skills, and perhaps a little sedation. Although no, you've been preparing for this climb your whole life. To avoid getting lost in the maze and rocks, it would be wise to use satellite imagery or, more likely, drones, which will find the easiest route to the goal imaginable. It's not just the abundance of mountains that awaits you, but also the altered landscape that makes the journey difficult. It will be less and less passable. For example, dogmatic rocks formed by the cooling on the Martian surface of lava from lingering volcanic channels or a crack in the Martian crust, such as realists, fears, whales, antisemites, and basalt. And while the terrain will be mostly covered in red planet dust, some places will still be exposed. You'll be able to see volcanic glass, small crystals called trace elements, and larger particles of porcelain-like secretions underfoot. It would be incredibly difficult to traverse such a heavy section in Martian conditions, because the atmospheric pressure at the top of Olympus is only 2% of the pressure typical of the average Martian surface. By comparison, the pressure at the top of Mount Everest is 25% of that at sea level. In addition, you have to consider lethal factors such as temperature variations. In summer, the red planet can warm up to 20 degrees Celsius, and at night the temperature drops to 90 degrees Celsius. Radiation is also not to be forgotten. For a year of life on the red planet, such a traveler will accumulate about 15 röntgens of ionizing radiation, which is 300 times more than the maximum annual dose for workers in the nuclear industry. But let's believe in a miracle, or rather in future technologies, or rather fantastic technologies of the distant future. thanks to which you have been not only alive for several weeks already, but have successfully approached your goal. And your group of travelers, in spite of radiation, temperature differences, pressure, abrasions, and fractures, reached Olympus. Although it did not work out for everyone, the length of the volcanic pit is 85 kilometers, with 60 kilometers. The depth of the hole reaches 3 kilometers due to the presence of 6 volcanic craters. For comparison, the largest volcano on Earth, Manolo Volcano in Hawaii, has a crater diameter of 6.5 kilometers. Now, standing at the highest point of the orbit, you have a spectacular view in front of you. Mars Olympus is so large that you can only see part of the many pits and depression formed by the calderon. Head-on flows, fissures, and a few impact craters cover the surface. Dust from the annual storms has traveled between the basalt, and the rocks and flows at this altitude. Your expedition is actually standing in space above most of the Martian atmosphere, and stars can easily be seen overhead in the atmosphere below. At the end of the resulting sky, thin blue water ice clouds begin to appear. Olympus covers such a large area that it cannot be seen completely from the surface of the planet. The distance required to view the volcano is so great that it would be hidden due to the curvature of the surface. Therefore, the full profile of Olympus can only be seen from the air or orbit. Similarly, if you stand on the highest point of the volcano, its slope goes over the horizon to the surface. Either way, you have conquered Olympus. The dirty suits of the expedition members show from the noses of the long weeks it took to climb the most enormous mountain in the solar system. There were 5 members of the expedition at the start, but only 2 managed to make it to the finish line. What happened to the rest? History is silent. Maybe it's time to tell you what you can celebrate nonetheless? For that, you brought along some marshmallow. Oh, wait, you're wearing a spacesuit. I wonder how long it would take to climb Mars Olympus with the problems you've mentioned. It's hard to say. However, in comparison, climbing Everest takes from 2 to 4 weeks. Since it is necessary to make frequent stops for the body to adjust to the altitude. If we imagine that the Martian Olympus happened to be on Earth, even more stops would be needed for acclimatization. More camps, more rest for tired travelers. Such an ascent would take 1.5 to 3 months. And that's on Earth. But on Mars, fortunately, that's not on the agenda for this generation. To travel to the Red Planet, the Arbiter performed 7 maneuvers. The 7th maneuver put the probe on a flight path to Mars. On September 24, 2014, the probe reached its goal and entered the orbit of the planet Mars. Nearly 1.5 tons, the probe carried with it 5 scientific instruments: color camera, methane sensor, photo, meters in line neutral hydrogen Lightman alpha neutral atom analyzer, XD sphere, and image building mid-infrared spectrometer. Their color camera function is designed to capture images of the surface of Mars, as well as weather phenomena, clouds, and dust. The methane sensor is able to measure the methane content of Mars' atmosphere with an accuracy of a few billionths and map the sources of this gas. Photo. A meter in the neutral hydrogen line will help study atmospheric processes on the red planet, as well as measure the deuterium content and ratio in its upper atmosphere, building an image. The infrared spectrometer will help find geothermal vents on the surface, if they are there, of course, thanks to its scientific onboard instruments. The probe, albeit modestly, has successfully gathered information about the red planet's surface as well as its atmosphere, and, of course, made interesting pictures of the planet Mars, and opens our gallery this stunning view. By the way, the Margolin probe took this picture, so if you've got some glasses lying around, use them immediately. The photo was taken from a distance of 70,500 kilometers from the surface of Mars. The photos further show Mars' southern polar cap and areas of raging storms. The photos were taken from a distance of 6,540 kilometers. The image once again emphasized that Mars is much like Earth in many ways, having many of the same systems that characterize our home world. Like Earth, Mars has an atmosphere, a hydrosphere, a dirt sphere, a sphere, and this sphere. In other words, Mars has systems of air and water, ice and geology that interact with each other to create the Martian environment. In this image, we're watching orbits take over this stunning view. Well, of course, in the image you can spot the famous Mount Olympus, which is located in the western hemisphere of Mars. Next is a giant system of canyons called the Marina Valley. Nearby lies a wide volcanic plateau with a trio of huge volcanoes belonging to the territory of Farsi province. These include Mount Ossia, Mount Peacock, and Mount Resurrection. All four volcanoes belong to the group of shield volcanoes. As we know, capturing a beautiful shot of Phobos is not easy. However, on October 15th, 2014, the Indian orbiter made impossible in front of us 4 frames in which 25 kilometers Phobos is seen against the background of Mars. Like many other small bodies in the solar system, Phobos is very dark. It reflects only 7% of the sunlight that falls on it. Mars' albedo is also low at about 15%, but it's more than twice as bright. Phobos. On October 19th, the comet from 11 sprinted at a distance of 185,000 kilometers from Mars, and it was filmed by almost every spacecraft that orbits or surfaces the red planet. The Indian probe was no exception. It took a series of images when the comet was between 180,000 and 130,000 kilometers away. Unfortunately, the comet did not live up to expectations. The size of its nucleus was less than 500 meters. Therefore, from such a distance and on the wide camera of the satellite, it looks like a small blurry spot. Nevertheless, the orbit probe tried to thank him. The canyon in front of you, now part of the Marina Valley, a giant canyon system on Mars. The image was taken on July 19th, 2015 from a distance of 1,857 kilometers. The canyon has large slopes and there are large deposits and layers of pure materials, perhaps even sulfate. The canyon is about 317 kilometers long and was named after an Earth officer mentioned in the Bible. Next, the probe arbitrarily observes dome view of an extinct shield-shaped volcano on Mars, located in the Farsi region. The volcano has relatively large dome slopes, forming the shape of the structure, leading some researchers to conclude that the volcano was formed from viscous siliceous or primordial lava, rather than the usual basalt and lava. Nearby is Mount Garcia, an extinct volcano on Mars located near the province of Fars. Mount Arse is about 435 kilometers in diameter and almost 19 kilometers high. The image was taken on April 1st, 2015, from an altitude of 10,000 kilometers. The volcano is named after a legendary Roman forest, Garcia Silva. Another image of the Martian volcano known as Mount Five Patience. It is one of the oldest volcanoes on Mars. As a consequence of its considerable age, it has quite a few radial ravines on its slopes. Also, the Indian probe Mongolia has received detailed photos from the highest mountain in the solar system, volcano Olympus, on the volcanic plateau Farsi. Near the planet's equator, Olympus volcano is more than 21 kilometers high, located in the western hemisphere of Mars. The diameter of its caldera is a fantastic approximately 70 kilometers, and the depth of this crater exceeds 3 kilometers. Due to its immense height, the pressure at the top of Olympus is only 2% of that found near the surface of Mars. The image was obtained from a distance of 55,000 kilometers. A technique was used to obtain this image. The idea is as follows. A series of frames are taken at different exposures and then combined into a single frame with the lighting conditions ripped out. The view covers the northern hemisphere of Mars. The polar cap is visible at the top. Judging by it, it's summer in the northern hemisphere. Let's go on vacation. In the lower part of the disk, you can see the Marina Valley. Only the northern hemisphere is visible here. Judging from the association in the polar regions, it is early fall or late spring. There is very little carbon dioxide ice at all. The North Polar Cap is surrounded by dark sands that were once at the bottom of the ancient Martian Ocean, and many other amazing and little-known shots. Unfortunately, despite the impressive arsenal of scientific instruments, there were no sensations, and the orbit mission turned out to be more technological than scientific. The most curious would have been the methane data. However, the methane sensor did not detect this gas in the atmosphere of Mars, most likely due to a malfunction of the instrument. The Mongolia orbiter continues to orbit around Mars to this day. After 7 years, this is surprising since India has never attempted an interplanetary mission. Mars, as we know, is very treacherous. In fact, statistically, about 50% of spacecraft sent to Mars fail either at launch, attempting to enter orbit, or landing on the surface. And India did it on the first attempt with a budget 10 times less than similar missions. They are rightly laudable. As of today, the spacecraft remains in good working condition with fuel for at least another year of operation. Thank you, probes, for the great pictures, and to the engineers for their hard work. You're doing a great job. Mars is the 4th planet in the solar system from the Sun, orbiting in an elongated elliptical orbit. The planet got its name in honor of the ancient Roman god of war. Mars is often referred to as the red planet because of the hue of its surface caused by its high iron oxide content. Mars belongs to the terrestrial group of planets in the solar system. In addition to it and Earth, it also includes Venus and Mercury. Among this group, Mars is the most similar to Earth because its atmosphere, albeit in small quantities, contains oxygen. There is water in the polar caps in the form of ice. Too low atmospheric pressure does not allow water to exist on the surface in liquid form. This planet, like Earth, has volcanoes. On Mars, there are winding valleys and depressions that look like riverbeds. Such formations may be related to water and glacial erosion and indicate that several 1 billion years ago this planet had a denser atmosphere and hydrosphere. That said, unlike Venus with its very dense and poisonous atmosphere, Mars is a more promising celestial body to look for signs of life and possibly colonization in the future. However, sending spacecraft to Mars is difficult. The distances between Earth and Mars range from 55 million kilometers when both planets are on the same side of the Sun to 400 million kilometers when the Sun is between them. The most convenient time for launching comes during the approach of the planets. Such periods occur about once every 2 years and last about 3 months. This window is used by mankind. Many 10-year periods. Now there are about 24 man-made devices on the planet Mars, which did reach the surface of the planet. But, as you know, the outcome was not all of them successful. 3 Soviet devices, 10 American, 1 British, and a skip burned. Built by specialists from the European Space Agency. The total mass of all the artificial objects that are now on the planet, including the crashed, more than 7 tons. Of course, not all are known, so the exact number of artificial vehicles that are now sweeping the Martian sand, it is impossible to name. A bit of history about Mars. In 1975, 2 automated interplanetary stations, Mars 2 and Mars 3, reached the surface of the red planet. Each carried a small rover samples in a box on the floor, tied to a stationary module in a 15-meter cable. The samples were to provide the first in situ images of the surface of the distant planet. Both were unlucky to land in the midst of that most terrible global field storm in November and December of '71. Mars 2 crashed on landing. Mars 3 landed without damage, and that was a real victory. The first successful soft landing on the surface of Mars in history. The station even started transmitting a signal to Earth, but stopped after 15 seconds and never made contact again. What happened is still unclear. The first fully successful mission to Mars was the pairing of the Orbital Station Landing Module mission Viking. The first Viking successfully descended to the surface and operated for over 6 years. Viking would have continued to operate had it not been for an operator error when updating the program. The vehicle was permanently silenced in the year B802M. The second Viking lasted 4 years, as long as the batteries worked. Viking took and sent back to Earth the first photographs of Mars, including panoramic and color photographs. Mars hasn't been visited since, until the Delta II carrier rocket lifted off in 1996 with the instruments of the mission, later named after Carlos Ghosn, and the Mars rover. The apparatus operated for more than 80. Olaf traveled 100 meters across the surface, sending back to Earth many photos of the Mars surface and research results. Since 2004, the story of a more thorough exploration of the red planet begins. One after another, 4 vehicles land on Mars, 3 Spirit rovers, the Spirit rover, the Unity Curiosity lander, and the Phoenix automated station. By now, Phoenix, Spirit, and Unity have left the Martian world. Curiosity, on the other hand, is still exploring the valleys of Mars. Later, the InSight probe joins in, a real professional at what he does. There are also apparatuses that orbit the red planet. Let's consider the most interesting data that the Mars explorers were able to transmit for all time. Viking apparatuses studied Mars for several years, both from orbit and directly on the surface. Experiments were conducted to detect microorganisms in the soil with no positive results. The major elements in the soil, according to the Viking spectrometer, were silicon 13%, iron 15%, calcium 7%, aluminum 5%, and titanium 1%. For the first time, chemical analysis of the soil was made and photographs of the surface were transmitted. The landers made long-term observations of Martian weather, and a detailed map of Mars was made using data from the orbital modules. Both landers took soil samples as a sample to analyze for the presence of life. Relatively high chemical activity of the soil was detected, but unambiguously their traces of microbial life could not be found. The Mars Odyssey orbital probe, launched in 2002, managed to detect large reserves of water on Mars. It became known that in some areas at a depth of about 45 centimeters is a rock consisting of frozen water to 70% by volume. Later, this assumption was confirmed by other instruments. But the final question about the presence of water on Mars was resolved in 2000 when the probe Phoenix, landed near the North Pole of the planet, received water from the Martian soil. Orbital probe Mars Express, sent in 2003, found in the atmosphere of Mars methane, which may indicate the presence of life on the planet, because methane cannot stay long in the Martian atmosphere. Therefore, its reserves are replenished either as a result of microorganisms or due to geological activity. And thanks to the images, researchers were able to examine in detail the amazing landscapes of Mars. The Mars rover Unity lander has determined the distribution and mineral composition of the rocks and soil that surround the landing site. And when the soil was analyzed, it became clear that there may have once been life on the red planet, as the necessary chemical elements carbon, hydrogen, oxygen, nitrogen, and sulfur were found. During its mission, Curiosity repeatedly recorded methane emissions into the planet's atmosphere. Based on the data from this rover, the researcher came to the conclusion that on the red planet are present complex organic compounds. The question of their origin remains open, and it is not yet known whether these compounds are the remains of organisms, the result of chemical reactions with various rocks, or they got to Mars together with comets and other space objects. Other than that, the rover is taking stunning pictures and continues to explore the landscape. The InSight space probe recorded Mars shaking on the planet for the first time in history. Such events can tell about the internal structure of the red planet. The apparatus also managed to record wind noise. In addition, on the automatic station, which will remain at one point throughout the cycle of research, installed equipment for measuring the temperature of soil layers, as well as a drill 6 meters long. A total of 44 missions have been officially sent to Mars in the history of Earth's space exploration. Automation of their spacecraft of different countries. Of these, 16 missions are successful, 7 partially successful, and 21 missions failed. In 2020, when there will be another rapprochement of our planet with Mars, several missions of different countries are planned. The second phase of the Russian-European ExoMars project will begin, providing for the delivery to the planet's surface of a descent module with a landing platform and an automatic rover pastor. There are also plans to launch a fifth planet HOD Mars 2020. India intends to send a second probe Mongolia 2 to the Red Planet. China is planning a mission that includes Mars exploration with an orbiter and a rover. The Arab Emirates is preparing to send its first Mars rover to the planet. In 2022, a Japanese automatic station may be launched to deliver soil from the Mars satellites Phobos and Janus. In 2024, Russia is going to repeat the attempt to collect samples of matter from Phobos. Project Boomerang Expedition. As we can see, the mission to the Red Planet is only gaining momentum. Mars gave mankind the hope of meeting other forms of life, or at least finding their traces. Therefore, for several centuries, the Red Planet has been a source of inspiration for scientists, science fiction writers, poets, and many others. Today we know quite a lot about Mars. Obviously, there are no intelligent life forms on Mars. What, then, have we lost on Mars? There is a simple answer: there is a stimulus for further development of all mankind, even if it's very modest. Mars awakens in people and good feelings of pioneers, explorers, and creators. Does it? And environmental. From time to time, we hear loud declarations of space conquest. Now, a huge and influential company called LPH has decided to reaffirm its ambitions to colonize Mars. Namely, that within the next 20 years they intend to send 1,000 spaceships, 1 million people, and the same number of tons of cargo to the Red Planet. So, is this a ploy from a fairy on New Year's Eve? Or is such a thing really possible? Well, we suggest to look into it. It is worth mentioning that Company X has a clear plan that will ensure the flight to Mars 10 space trains a day. However, the world has been hearing about these very electric trains between Earth and Mars from Elon Musk for not the first year. The project was officially presented 8 years ago at the International Congress of Astronautics. Then were also announced, and details of the transport system will consist of a rocket with a height of at least 122 meters, or about 40-story house ship and refueling tanker. In the first years, the system will be able to transport up to 100 people to Mars for one flight, further up to 200. True. Then the company believed that the first flight could take place as early as 2022, and in 2024, people will be delivered to Mars. However, at the moment, the maximum that we have observed is stylish mannequins traveling in Earth's orbit. That's why experts are divided. Some frankly call it nonsense, and some consider the project quite real, as there are huge sources of funding. Be that as it may, the work on the Super Heavy rocket and Senior is gaining momentum, despite all the failures that still haunt it. Recall, the first test launch of Senior was in April last year. The ship was destroyed. The second flight test took place in November 2020, the third and exploded first stage. The flight this March lasted already 50 minutes, but at an altitude of 80 kilometers, communication with the Senior stopped. After which SpaceX also reported a loss. New flights will take place soon. Accidents are accidents, but there's still steps forward, as each flight is better than the last. And as Musk stated, The company plans to make 6 flights of its super heavyweight this year. This is certainly good news, and we can be sure that the company will still succeed in not only taking off and landing, but also walking into the orbit of the Moon and Mars. Not from a mannequin, but by real people. Yes, it will happen someday, hopefully in our lifetime. But the question is different. Mars is a relatively distant, cold, uninhabitable planet. Why, how, and why? Company X so is interested in this too. Share your opinion in the comments. Because the truth is that space is extremely hostile to man. And a manned mission to Mars with current technology, it's a one-way ticket. In addition, the problem of delivery to the surface of Mars' Million City requires not only a rich imagination, but also answers to specific technical questions. And the main one of them, what mass should be taken from the Earth into Earth orbit to move 1 million people to Mars? Or let's be more modest, at least 1 million of them at the end of the 50s. Wernher von Braun and his project to send an expedition of 70 people to Mars was supposed to collect 38,000 tons in Earth orbit. That's fantastic even by today's standards. 500 tons per person in 1962. Sergei Korolev, developing the interplanetary program, presented to the expert commission quite realistic project of the expedition to Mars, in which to send 3 people were supposed to collect an orbit of an artificial satellite of the Earth total mass of 500 tons at 165 tons per person. Over the past half-century, these data could not be reduced, even in projects focused on reusable electric jet ships. It is assumed that there will be no return of people to Earth, and the initial mass per person can be halved to 80 tons. So the question becomes, how can you fit 100 people into a rocket that is only slightly taller than the Saturn V? Yes, it is possible, but not for colonization, just an easy walk to the Moon and back. Yes, at this point the SpaceX Super Heavy rocket in its current form will not send 100 people to Mars. At least not alive. Water recycling and oxygen generation systems for that many people would take up a lot of space, and sufficient provisions, even simple climate control, would take up almost all the space. But 10 people is very possible. There's enough room for them, and they will feel very free. Of course, half of it would be filled with resources and cargo, and of the other half, most of it would be common space. At this point, the heavyweight SpaceX isn't a Mars ship? Not yet, no. It just can't get there with people on board, let alone return. Even if you build it such a balance of fuel that it will be enough to land, it will have to be refueled on the surface of Mars. And to do that, you have to build a base there with fuel extraction and processing. And this will be done by robots, and they're not very good at it yet. But that doesn't mean Linux's plans are ridiculous. They're far from it. The ships themselves are great, as are all the people involved in this project. If everything works out, they are the future. Plus, the new propulsion system with X has potential. Revolutionize manned spaceflight by helping people get to the planets of the solar system much faster. As a reminder, Senior and his super heavy carrier rocket are powered by the Phantom engine, which was designed from the ground up. It is a closed-cycle engine with full gasification of propellant components, running on liquid methane and cooled liquid oxygen, and is the most complex engine in the world. Rocket engines of this scheme work in such a way that the exhaust gases from the gas generator are directed into the main combustion chamber. This lowers the operating temperatures of the gas generators and increases fuel efficiency. Not to say that this is an incredible breakthrough, but that the company is continuously making strides that bring them closer to their goals is evident. SpaceX is currently the leader in space launches, partnering with private companies from around the world, NASA and other agencies. It is difficult to compete with the company because of the extremely low cost of services and high performance. Overall, it can be said that the approach to space exploration and travel has changed significantly since X entered the market. Thanks to the lower cost of launching and reusing rockets, space has become more affordable. Exactly who or what it is for is an open question. Either way, space, especially deep space, will be explored by robots, at least for a few more decades for sure. And then time will show in what direction mankind will develop. Maybe we still have a chance to get closer to the stars? Today, Phoenix became the first spacecraft to land in the polar region of Mars. The last session with the spacecraft took place on November 2, 2008. A little later, the end of the mission was announced. What happened to it? What did it discover, and what data did it manage to transmit to Earth? We offer a detailed look at this amazing mission. The very name Phoenix was given to the spacecraft for a reason. Few people know, but the Phoenix really revived. The fact is that after the failed mission to Mars in 1999 had to cancel the planned launch of another vehicle, which was designed on the basis of the polar apparatus and inherited its design shortcomings. At first, the ship was placed in storage, but later retrieved and designed on its basis a new one. It is safe to say that it was reborn from the spare parts of failed projects. Phoenix's journey to Mars began on August 4, 2007. For 3/1 months until October 26th, operators tested the systems. The flight of a new landing module and suite of scientific instruments. Meanwhile, the Red Planet's 3 artificial satellites Mars, Odyssey, Probe, and Mars Express adjusted their orbits so that all 3 would be able to relay and record data during the new station's re-entry, descent, and landing. The 2 Mars rovers, which also participated in the preparations, were not idle, mimicking the Phoenix lander signals for many months, and thus allowing the orbiter's ion modules to test relaying. From several potential locations, an area in the zone north of the shield volcano Alba on Mars was selected. The selected area is an avalanche between 2 towns of low hills called Scania with a 10-kilometer crater. The movie was given on its eastern border. During the winter months, the North Polar Cap covers these areas, and in the summer it recedes, leaving behind one of the flattest and most rock-free polar regions. On Mars, during the search for Phoenix's landing site, such flat areas are painted or mapped in green, hence the tentative name Green Valley. The area on the other side of the planet was originally considered a favorite, but imagery showed that there were too many rocks, and rocks, as we know from previous missions, can be a huge problem for the arrival of a new guest. Everything was prepared, and on April 10th, Phoenix made its first true correction to ensure entry into the Mars atmosphere and landing in the specified area. The spacecraft was deployed at 145 degrees and then turned on its engines at the 30th second. At the end of the pulse, it oriented itself with its antenna pointed sharply toward the ground. The maneuver was so precise that the second subflight correction scheduled for May 10th was canceled. For the last 2 weeks of the flight, the spacecraft was accompanied almost around the clock by the long-range network stations. And finally, on the morning of May 25th, Phoenix felt the pull of Mars, and it was then that the station's speed relative to the planet began to increase rapidly. On the morning of D8, it was about 2,800 meters per second. D30, it increased to 3,800 meters per second, and by the time it entered the atmosphere 1630 to 5,760 meters per second. A moment and the craft enters the plasma, which typically blocks the passage of radio signals for about 2 minutes. Still, the radio report through the orbital probe Odyssey turned out and markedly reduced the tension. Usually reignited in the mission room, the signal to open the parachute came 7 seconds behind schedule. Screen reset and normal radio and locator operation were then confirmed. And here, in this image, we can see a truly unique shot of the Phoenix probe descending against the backdrop of Ham Crater, Dal, as the probe descends. It's worth mentioning that Phoenix has a mass of 410 kilograms. Of this, 67 kilograms are for fuel, 59 kilograms for scientific instruments. During the approach to the planet and during the descent, the flight stage 82 kilograms is dropped. The tail fairing is 110 kilograms and the frontal shield 62 kilograms. The total mass in flight is 664 kilograms. There is a signal of touchdown on the surface of Mars. The landing was successful. The apparatus remains on the polar plane and begins operations as planned. The team is looking closely at the images. First fragment of panorama transmitted May 25th by Phoenix. The fine light-colored rocks and darker sand are partly swept away by the jets of the engines. Roads or grooves separating from each other. 5 polygon. A typical view of the resulting soil over the eternal world of golden. Next, the manipulator camera was able to look under the Linder from its mast, and the camera could only see one landing support out of 3, and wanted to make sure that the other 2 were also securely on the ground and that there were no large rocks under the hull of the Phoenix. This attempt brought an unexpected and very important result. Directly below the probe, the camera saw a sand-free surface area that looked very much like ice. It seems that the sand in this place was blown by the jet of the landing engines, thus exposing a layer of ice at a depth of 5 to 15 centimeters. However, the researchers saw another possible option, that it was a crust. Mounted seep to the surface with solutions of magnesium and sulfur compounds. On Saturday, May 31st, it would seem that the Martians found Phoenix. Having left their trail, they went after the others. But in fact, it is only a trace of the manipulator bucket, which first touched the soil of the planet. For the first touchdown, a Bigfoot point was chosen in the Kings of Worms area, away from the manipulator's working area. In addition, the camera on the manipulator took a series of images of the Snow Queen backlit by LED sources. However, no good color image was obtained. June 1st, 2008, on the 7th working day on Mars, for the first time scooped a handful of Martian soil with the bucket. The first grooves were named Dodo. Its walls became almost vertical, it didn't crumble, and the soil inside turned out to be a lump of absorbent cotton. Not too solid, but it didn't crumble into buckets either. A brightly colored material was visible at the bottom of the dig. At first glance it appears to be ice, but it's actually a purposeful crust created by the outpouring of liquid from the meteorite impact that struck the crater. They were given. On June 3rd, the Martian excavator made another test button in the same spot with detailed photography. The manipulator worked its assignment without problems. From the second time, the canard deepened to 4 centimeters, and the white matter on its bottom and walls became even more visible. The Martian material was unexpectedly stickier than in the previously explored areas. A little later, the probe bucket skillfully moved some of the sash material for closer examination. Imaging confirmed the success of this operation. In all, about 1,000 grains of sand as small as 0.01 millimeters came into view, which the experts attributed to at least 4 different minerals. Among them were larger black and shiny and smaller and reddish, similar to the dust particles introduced earlier. On June 12th, on commands from Earth, Terra closed the flaps of cell number 4 and began a daily procedure of heating and analyzing the samples, first to 35 degrees Celsius, then to 175 degrees Celsius, and finally to 1,000 degrees Celsius of melting. The analysis showed that the particle was of volcanic origin, essentially glass that had experienced weathering and turned into smaller particles with high iron content. Other samples showed that the soil also contained 1.5% water. The signs of water were unmistakable. The instrument detected oxygen and hydrogen, and the energy consumption of the stove during the ice melt increased by the expected amount. Of course, ice had been detected much earlier, but now Phoenix was the first spacecraft to taste and touch Martian water. After studying the images and results, the mission managers decided to try to load these samples from the soil-ice interface into the zero-cell gas analyzer. It was a very difficult instrument to analyze more thoroughly, but that's small consolation if it fails to work because of a mistake. It was unfortunate, but it happens on complicated missions. On August 4th, the atomic force microscope successfully examined part of the sample for the first time. Enchanter and showed scientists soil microparticles with a diameter of about 1 micrometer or 0.0001/1000 millimeter. The principle of this microscope is to admire a super thin silicon needle of a grain of sand lying at the bottom of a special hole in the substrate. By the way, this is the first case of using such a device in the history of astronautics. At the end of the mission, the following results were obtained. Detected significant reserves of water ice under a thin layer of Martian soil. Chemical analysis of the soil showed a slightly alkaline reaction and water, soluble compounds such as sodium, calcium, and chlorine were found, which means the soil could very well be suitable for future colonization missions. At least it's feasible. For the entire period of work, the Phoenix probe took 25,000 images, which represent a huge amount of valuable information about the composition and properties of the soil sample of the planet Mars. 3 unique Phoenix images that have undoubtedly made Mars history cannot be overlooked. Sunrise on the planet Mars. The Great Plain is covered and not and beautiful. A snapshot of a field vortex on the red planet, but everything comes to an end sooner or later. On November 10th, 2008, it was announced that the lander was terminated. Instead of 3 months according to the plan, the probe worked for more than 5 and failed due to a sharp drop in the charging current from the solar batteries in the conditions of a dust storm. And now, almost 10 years later, the orbiter has taken a picture of Phoenix's descent site. It's still standing on the planet's surface and continues to be covered in a thick layer of Martian. Yes, Phoenix's mission was complex and important, but the vehicle accomplished all of its tasks and relayed crucial information back to Earth. Thank you, Phoenix, and the entire crew of this truly historic journey. Well, a dusty, cold, desolate world with a very thin atmosphere, all of which is the 4th planet from the Sun, Mars. However, Mars is also a dynamic planet with seasons, polar ice caps, canyons, and extinct volcanoes. Many missions have been organized to the planet Mars, ranging from probe flights to surface rovers. Today, the international fleet of 8 orbiters is studying the red planet from above, and the Curiosity rover is exploring the surface of Mars. Moving Severin with the helicopter, the InSight lander, as well as China's Mars rover Ju, which, though for health reasons, never came out of winter hibernation. All these robotic explorers have uncovered plenty of evidence that 1 trillion years ago Mars was much wetter and warmer. A warmer atmosphere, and have also sent various recent data back to Earth, which we'll talk about in this issue. And we're going to start with the orbit of the red planet. Well, it's been more than 20 years since the Odyssey orbiter is still studying the Martian surface, having circled the planet more than 4,000 times. In that time, the probe has mapped not just the landscape, but the minerals. On the Martian surface, Odyssey has found deposits of small amounts of ice where there shouldn't be any. The probe continues to observe how the climate and weather changes with the seasons. Meanwhile, the probe, launched in 2013, continues to study Mars' atmosphere and investigate how and why it changes. Recent findings have reported that the solar wind is responsible for Mars' loss of atmosphere over the years as it shields the effect of the global magnetic field. Was lost due to the cooling of the planet. But the embryo spacecraft is monitoring any potential landing sites on Mars now and in the future, and in this regard it finds sometimes something really interesting. For example, just recently the XC camera aboard this probe took images of sand dunes covered in frost just after the winter solstice. The fact is that when winter comes to Mars, its surface turns truly unlike anywhere else in the world. The coldest is seen at the poles of the planet, where temperatures reach -123 degrees Celsius. But no matter how cold it gets, you can expect blizzards, snow drifts, and snowman on Mars. It won't be easy to make a snowman. Nevertheless, the planet is experiencing a unique winter phenomenon. 2 types of snow can be found here: water ice and carbon dioxide or dry snow. Because the Martian air is so permissive and the temperature is so low, the carbon dioxide water ice snow is lost and turns into gas before it even touches the surface. And if you brought skis, You would have to go into a crater or up a cliff slope where the snow could accumulate on a sloping surface. Snow also only falls on holidays in larger amounts in the coldest extreme areas of Mars at the poles under cloud cover and at night. Also thanks to the orbiting probes. Now we know something about Martian snowflakes. Normally, when they freeze, water molecules cling to each other. And these snowflakes on Earth have 6 faces. The same principle applies to all crystals. The way the atoms are arranged determines the shape of the crystal, but carbon dioxide ice has a symmetry of 4. That's why snowflakes made of dry ice have the shape of a cube. Such snowflakes would be smaller than the width of a human hair and resembles cold dust. But perhaps the most fabulous discovery occurs at the end of winter, when all the accumulated ice begins to melt and burst into the atmosphere. In doing so, the ice takes on bizarre and beautiful shapes. This melting also causes geysers to erupt. The transparent ice allows sunlight to heat the gas beneath it, and this gas eventually bursts outward, throwing dust onto the surface of the fan. That's the kind of recent data we've gotten from orbiting probes on the planet Mars. But let's go down to the surface of the red planet and take a look at the work of the locals and laborers. Rover. We'll start with the Curiosity rover, which has been exploring Mars since 2012 and continues to amaze us, despite the holy wheels plagued by Mars' harsh climate. For example, in February this year, the spacecraft observed the first sun rays peering through clouds at sunset. Yes, Martian sunsets have a unique mood, but it's entirely possible, albeit a fairly rare phenomenon. While most Martian clouds hang no more than 6 kilometers above the surface and are made up of water ice, the clouds in the latest images are even higher up, where it is particularly cold. This suggests that these formations are made up of ice containing carbon dioxide or dry ice. And here we observe the rainbow pony-like appearance of a fancy cloud when illuminated by sunlight. Such magical shimmers mean that the size of the particles and crystals change throughout the formation over time, which is also quite rare. Among the latest discoveries made by the veteran Mars rover, also rock textures indicating the existence of lakes. When Curiosity reached the sulfate nose of a new block in the vicinity of Mount Sharp, researchers thought they had seen the latest evidence that there were once lakes in this area of Mars. This is because the rock layers here were formed in drier conditions than in regions explored earlier in the mission. Sulfate and salty minerals are thought to have been left behind when the water dried up to the last drop. Once upon a time, 1 trillion years ago, the ripples on the surface of a shallow lake had mud or sediment of its bottom. Over time, the sediment formed into a strangely textured rock that is the clearest evidence of waves and water ever found. Curiosity. Meanwhile, the Martian landing module InSight, covered in a thick layer of dust after a storm, is living out its final days. But the spacecraft is not standing idle and was able to transmit important data. The probe detected another tremor. In itself, it is not unexpected, but it is the largest of them, the power of which is 5 times the strength of the previous record holder. Its magnitude was 4.7, and the echoes continued for 10 o'clock after the event. Other tremors echoed for only about an hour. The team estimated that the source of the tremor was about 2,000 kilometers away from the landing module. Nevertheless, the seismic waves reached the spacecraft's detector. The cause is believed to be a plume beneath the surface mantle. Strong seismic activity is of great interest because it allows us to learn more about the planet and its composition beneath the surface. Generally, since the InSight lander landed on Mars, more than 700 series of tremors have been recorded. It seems that Mars is much more alive and active than we thought. And what can we say about the performance of the youngest rover? Now, Severnov, this rover will begin its third year of operation at Jezira Crater 6. The nuclear-powered, wheeled rover is studying geologic features to look for signs of ancient microbes of life and to better understand the processes that shaped the surface of Mars. Severin has now examined and collected data on hundreds of intriguing geologic features. In addition, the rover has collected 2 samples of Rigoletto and 1 sample of the atmosphere, as well as other specimens. During this time, the rover has already taken more than 166,000 images. For example, in this photo, Severin shows the collected collection of specimens on Mars. Not even the rover has taken a picture, it hasn't. Future NASA missions will help collect these samples back to Earth for in-depth analysis. Well, Mars exploration continues until today and has already given us a lot of valuable information about the red planet. But despite this, Mars is still a mysterious and largely inscrutable object that may be hiding many more secrets, waiting to be discovered. Since time immemorial, people have been interested in the structure of the world we live in and then in the worlds beyond. And although our understanding of the universe has become much more accurate over the last 100 years, it still holds many mysteries, including, are there other alien civilizations? In sci-fi books and movies, human beings encounter aliens time and again. Their appearance may be unusually different from us. They may look like birds, plants, or generally something fantastic and inexplicable. But can we determine what representatives of other star systems might look like? Actually, it can be done. At least, we will try and start from what you and I look like and why exactly so and no other way. You probably know that all things in the world, both you and inanimate, are made up of molecules, and molecules are made up of atoms, and atoms are like little Lego bricks. Like Lego bricks, you can build a scooter, a chicken, and a rocket pack. Also, atoms, combining with each other in different combinations, turn into different things from simple water to Nicolas Cage. There are now 118 such bricks of atoms. All of them are listed in the Mendeleev table from the school chemistry textbook. In living cells, there are other chemical elements, sometimes very important. For example, humans need calcium, which makes our bones, teeth, and hopefully nerves strong. Or iron, which is part of our red blood cells. And, say, marine animals such as salmon, storms, and I'd contain unusually high amounts of the rare metal vanadium. But what it's used for is still unclear. However, if we take all living organisms living on Earth, we see in their composition primarily 6 basic elements. But why? Why, out of the 80 available building blocks for creating life on Earth, are only these 6 working? Why did it happen that, with an overabundance of parts to assemble a space shuttle, we are content with an all-blue tractor? Logically, the most common atoms found in the universe were used to create life. But did they? Let's find out. So, the most common chemical element in our universe is hydrogen. Got it. In second place, helium. We didn't get it, but we have an excuse. Helium is an inert, that is, lazy gas that is extremely reluctant and rarely enters into chemical reactions. To create a living organism with its intense metabolism, such a gas is not suitable. What do we have next? Nitrogen is there, carbon is there, oxygen is there. And then there's neon, sodium, magnesium, aluminum, silicon, sulfur. Only phosphorus is 11th most common. It's not even in the top 20. But phosphorus is crucial to life on Earth. It is part of the DNA and RNA molecules that store the hereditary code and allow organisms to reproduce themselves. It's also part of ATP and ATP molecules, which are responsible for transferring energy within a living cell. Without them, life would be impossible. So our hypothesis that nature chose what was at hand to create life is the most common. It doesn't stand up to scrutiny. And to tell you the truth, researchers have yet to find the answer to this very riddle. Maybe they will someday. Or maybe there was never any mystery. Is it just a coincidence? Think about it. Of our magnificent six, the most important elements for life are carbon, hydrogen, and oxygen. Why? Let's start with carbon. Carbon is the most important element of all. There's a reason why the science of chemistry has been divided into organic chemistry and inorganic chemistry since high school. Due to their special properties, carbon atoms can form long chains, rings, and even nets with numerous hooks on their sides. These hooks allow other atoms to be attached. This produces very large and complex molecules such as proteins and nucleic acids, or, say, the phosphate lipids that make up the membranes, that is, the strong walls of living cells. Without such molecules, the contents of a living cell simply fall out into the environment. And in such conditions, it will be difficult to coexist in the human world. But carbon is not the only element. Valentina, 4. There are others. For example, germanium, lead, and tin. But silicon is particularly curious. Silicon is very common. It's the 10th most abundant element in the universe. Back in 1894, the German astrophysicist Julius Steiner pointed out that silicon is similar to carbon in many ways and could be considered the basis for alternative and unearthly life. This is why more often than not we envision alien life as not like our own, something like the alien race from Star Wars. Babylon has 5, or the creepiest of them all, the Andromeda mass effect. But the truth is that alien life can only be like ours if the conditions on the alien planet are similar. If there is air made of oxygen and nitrogen and liquid water, if there is normal, according to our concepts, temperature and gravity. But do we have to? Astronomers believe that of all the abundance of planets, and they are only in our galaxy supposedly 2 trillion, similar to Earth, no more than 1%, and the rest are completely different. Let's see, Venus has an average temperature of plus 500 degrees Celsius. Lakes of basalt, lava, and molten lead. And rain drips from the sky and concentrates on sulfuric acid. On Titan, Saturn's satellite, the temperature is minus 180 degrees Celsius. Rocks are made of water-monthly ice, and it drips rain from the sky made of liquid methane, which we call natural gas, on which they heat canned food on holidays. And there is such a type of planet as a carbon planet, where rocks and stones are made of diamonds, dirt is made of fuel oil and tar, and rain is natural gasoline. Can man or other earthly life survive in such conditions? It will not be easy. And now back to the ancients. Just as a carbon atom joins 4 hydrogen atoms to form methane, so an atom of silicon attaching 4 hydrogen atoms, the silicate force is formed. Silicon salts are the carbonate analog of the carbonate of carbon salts. Finally, like carbon, silicon can form long-chain polymers. Say, carbon-oxygen chains form one of the plastics polyformaldehyde. Similarly, silicon. Oxygen chains form the silicone we all know well, which is abundant in some people. So there's a lot to fantasize about. Our carbon-based organic molecules cannot tolerate high temperatures at just plus 70 degrees. A person can already get burned by a metal object. A temperature of plus 250 degrees Celsius will be the last tan in our lifetime. But silicon compounds are very resistant to high temperatures. Of course, there are complications and serious objections. For example, if carbon dioxide is a gas, then silicon dioxide is a solid substance quartz, that is, ordinary sand. In any case, on the surface of the earth, you and I, when we breathe, inhale oxygen and inhale carbon dioxide. And if we suddenly rearranged from carbon to Kremlin, then we would exhale sand. It would just clog our lungs in a matter of minutes, and we'd hardly survive. So respiratory organs and oxygen-silicon life forms, if they exist, must be arranged quite differently. Objection 2. Ecological. If there is an organism that breathes oxygen and excretes silicon dioxide, there must be another organism that absorbs silicon dioxide.